Good evening, everyone. I'm your host, Chris Modnitsky from the Fort Worth Astronomical Society. We have some changes. One, I'm no longer the president. Yay! We have term limits. There's a reason for that. So while I am no longer the president, I am still going to be doing these star parties. I'm still going to be doing something. For as long as we're going to be under this COVID-19 crisis, we're going to have to do this. Tonight, we are back down here as last time. We're down in Grandview, Texas. We're under some dark skies and full of bugs. So it's a bit warmer than it was last time, but I've got bugs everywhere. I've got stink bugs. I've got mosquitoes. I've got June bugs. You name it, it's over here. It's rather annoying, but it's fine. Oh, and they're all over the monitors and the computers. We'll survive. Also tonight, I have with me a special guest. We have, let's see, there he goes. We have Andrew Turner from Fort Worth Roots.
Nailed it. Hello, everybody.
It's a local podcast. And why don't you tell us a little about yourself and what you do?
Okay, well, first of all, hello. I'm also recording tonight for my podcast, Fort Worth Roots, and it's a variety interview podcast. We reach out to local artists, musicians, and interesting groups like this. So Chris was nice enough to let me tag along. Super excited to be here. I have killed at least 1,000 mosquitoes already. I was telling Chris, never a problem for me, but for some reason, maybe the energy drink, I'm getting attacked. Oh, I got a cat. Hi, buddy. But Chris, thank you for having me here, man. And I want to be as engaged as you'll let me, but I also don't want to get in the way.
So what we're going to be doing is
the bugs are intense, y'all.
Yeah. What we're going to be doing is our usual virtual star party. It is the summer. This is the height of the summer Milky Way. So last time we were able to see some stuff late at night. We're going to be able to see it a little bit earlier. Jupiter has already risen, so we took a quick look. We were able to see the Galileans on one side of Jupiter already. We didn't get that good of a view yet. I haven't messed with it. We'll be there. I thought that was a bug. That's a cat. Yeah, he's rubbing up against me.
Over here.
We also have dogs out here too. We have a lot of cicadas. I don't know which generation this is, but they're loud. You can probably hear them. If I don't say anything, you can still hear them.
Coming in good on this end.
Cool. So, all right. So we're set up here. I believe the telescope is aligned. Probably. Looks like it is. I'm sorry, all these bugs are kind of throwing me for a loop, and it's very hot. All right, so here's what's going on. We're doing these virtual star parties because of the COVID-19 crisis. We don't really have any choice. And this week we've got some additional information. The number of cases in the United States is going way, way up. On top of that, there are indications and reports that the virus is actually airborne and not just carried in droplets. So what that means is it is more dangerous. Well, it's always been dangerous. The issue is that we now know that it is more dangerous. So we have to take additional precautions. Now, when we were setting up, I will say, Andrew and I were both wearing masks. So this is a surgical mask. I have an N95. That I was wearing typically, but it is rather hot outside. What we are doing is we are practicing social distancing. So Andrew is actually a good 12 feet.
At least, because this is an 8-foot table. So.
Yeah, I would say 12 to 15 feet away from me. And on top of that, we're watching where the wind is coming from. So the wind is from the south in this direction. The telescope is actually pointed towards the north. And this time I have it pointed in the right direction, so we're not going to have to spend an hour or so just getting it aligned. All that stuff was done ahead of time. That's nice. Let's see. Cool. All right. I'm checking out the messages on the YouTube channel. So if you have any questions, if you have any comments, go ahead and put them in the chat. It takes me about 30 seconds to see as they come in. It is not instant. Yeah, we're just going to go ahead and start getting right into it. Social distancing. All right. So we are far apart. The wind is coming in from the south. Very, very light breeze, but we are crosswind from each other, so that hopefully, actually, definitely, anything that's coming towards him is going to get blown out in the field. Anything that's coming towards me is going to be blown out at my telescope, which is covered in my germs anyway. I do actually have alcohol, not medicinal alcohol, alcohol to clean my hands with, and plenty of water to drink. And I will say this, alcohol and astronomy don't mix terribly well. One of the problems is it does affect your eyes, so the seeing gets worse the more you drink. So typically, we don't drink when we do observing. I know. I don't. There are probably people who do. But I try to make it a policy not to drink, because after the night is over, I would like to go home. And I would like to make it home. So I don't drink. But right now, it's nice and warm, and water is fantastic. Absolutely fantastic. I just have to keep drinking more.
While he's drinking water, I'll tell y'all that he's not just putting on a show for you. He was very vigilant whenever I got here about the social distancing and wearing the mask. So stress on how important that is. But yeah, not just a show for the cameras while they're on. This is actually the first time we've removed our masks, just once we got situated and turned everything on. So, but I appreciate you looking out for safety, Chris.
Not a problem. So here's what we're going to do. I am going to figure out how we're going to get this. That's not what the way I wanted. That's not what I wanted. That's kind of what I wanted. All right. So Andrew is doing his podcast, but I also want him here as kind of a layman to ask questions, so that he can kind of he can be the audience for this. That a lot of times people don't really know what they're seeing. We can show an object. Let's say in a bit, when Jupiter's a little bit higher, we'll go ahead and show Jupiter. Well, okay, what does Jupiter look like? Well, why does it look that way? Why are the moons that way? There's a whole lot of stuff that we can talk about, and I come at it from the view of an astronomer, where I can give you information and stuff that I think is really cool, but it may not necessarily be the question that you want to answer. This place is covered in bugs. I will just say it is covered in bugs. So I'm going to get the scopes ready.
Telling Chris that typically I do not use bug spray. I just don't ever need it, but tonight I'd be willing to probably drink a little bit of bug spray. It's pretty extreme. I don't think the cameras are picking up the bugs, doing it any justice, but these floodlights, these LED floodlights are really bringing them in.
Okay, so I've got this. All right, I've been having some issues with tech lately, and I'm not sure how well this is going to work out. So we are going to test this, and all right, so pardon the screen. So yeah, we got to do some testing. The device mangler. Everyone loves the device mangler from Windows. So what I need to do is make sure that my cameras are on here. Yeah.
I wish I could help, Chris. I have no idea what you're doing over there.
Yeah. Okay, so here's what we're going to do. What I'm trying to do is I'm trying to bring up the utility for looking at, or for using one of the cameras. And I just upgraded this. This is called Backyard EOS, and we typically use it, but it's had some issues lately. It should not have any issues lately, and that's the thing which bothers me, is that it was working just fine, and now it's having problems. So what we're going to do now is get a... we're looking at one of the cameras, and I think that's a star. That looks like it's a star. But I got to get a focus on something else. So here's what we're going to do. We're going to swing it over on Jupiter And let's see just how well this is aligned. I'm hoping it's well aligned. I'm also hoping that I didn't tangle up my cables. Oh, I sure did. Well, there we go. That's fine. Well, that's not good. There's my problem. Okay. Technical difficulties. I ripped cables out of my hand controller.
Ooh.
So, what that means is, this is now useless. That's a stink bug. Well, that was fun. What is that? I have no idea what that is. Oh, that would be a grasshopper. Oh, I'm getting everything today. I swear I'm going to bring a billion bugs back home. Okay, so I've got my alignment. This will be less than a whole lot of fun, but that's okay. We'll figure out how this goes. So, Canon EOS T3i. All right, that's coming up. Will it connect? It's not going to connect. I don't know. So yeah, we're not going to be able to use Backyard EOS, which sucks, but that's fine. We'll use this control camera, camera settings, remote. Yeah, we'll just do this. So, what is going on with this? Mono 16. This is a Mono 16 camera. That's fine. Alright, so what we're doing first is we're going to swing this over, and I want to look at Jupiter. Let's see, does anyone have any questions or comments while we're going on? Okay. Alright, fine. So, what kind of telescopes do we have? Let's see. There are two telescopes on here. One is a Astrotech 8-inch Ritchie Cretan carbon. That's the black one that's right here that you can sort of see. It's that one. And behind it is a Teleview 101 apochromatic refractor. So the first one uses two hyperbolic mirrors, and the other one uses a set of 4 lenses to make its images. The black one, the Astrograph, it is a dedicated astronomical camera, or a telescope. It is meant for taking photos. It does a pretty decent job visually, but it really is meant for photography. Now I got to figure out what we're looking at. Okay, so and one of my cousins is driving, pulling a trailer or something. Yeah, he's pulling a trailer, so hopefully it won't bother us too much. I'm going to get this on Jupiter and see how well this works. Well, the problem is I'm a bit short. Oh, it's nowhere near Jupiter. Oh man, it's going to be one of those nights.
Can I steal the mic for a minute while you're doing that?
Sure.
I'll tell you guys a little bit more about Fort Worth Roots. Not a whole lot to tell you because it's just getting started. Our launch date is actually July 20th, and whenever this airs on Fort Worth Roots, this will probably be end of August. So we've got 10 episodes already recorded, processed, and ready to launch. I'm just working on show notes and some finer details. But you can find all of our show notes and information at FortWorthRoots.com, and it's got all our social media links on there and stuff. But thank y'all for having me out. Super excited.
So for our site, it is FortWorthAstro.org. We also have Facebook.com/FortWorthAstro and YouTube.com/Fort Worth Astronomical Society. Okay, now I have not used this before, so I've got to figure out how to get this thing. And what I need to do is live view shot. Let's see how this works. Sweet. Okay, so we're pretty close. There we go. So what are we looking at? We are looking at Jupiter. Oh, that's not what I want. Oh man.
You're on the wrong planet?
No. I can actually see it here. Focus is fine. Live mode. This is fine, but it is not. this does not have all the features that I'm really hoping for. Yeah, I've got two live views. How am I got two live views? I guess it'll let me zoom in on one. Yeah, that's a zoom view. Okay. So what I need to do is, all right, so here's what we got. 1, 2, 3, 4. We got 4 moons of Jupiter, and Jupiter's right there in the middle. What I want to do is get another camera on there so we can do something better. It'll take a little while to do, but that's okay. We can still talk through this. So what we're seeing right now is Jupiter. Now, it's really, really, I've got some color on it. It's really moving, okay? And that's because it's very low on the horizon. I would say, how much is that? Like 1 hand, 2 hands. I got 10 degrees off the horizon. That's pretty low. Typically, we don't even look at stuff until it's about 15 to 20 degrees up.
Why is that, Chris?
There's a lot of atmosphere. So think about it this way. We want to look at something with as little air between us and it as possible, which means straight up.
Okay.
As close to straight up as we can. If we're looking down at the horizon, we're now cutting through a whole lot more air. And this is the same reason why sunsets are red and sunrises are red, is because the light that's coming from the sun is being refracted more. The blue light is, and it's getting scattered. The red light is making it through. There's just more atmosphere. But when it gets overhead, that blue light can come down and the sun looks white. The sun is actually white, even though we call it a yellow dwarf. So we want to wait until it's higher up. We want to wait until the image is going to be better. We can look at it now, and it's not a problem to look at it, but it's just not, it's not an ideal image.
Chris, will you pull that microphone a little closer to you?
This one?
Yes, sir.
Okay.
Thank you. Oh, that's much better.
Yeah, we're trying to do a dual microphone setup on here. I can't believe how many bugs are here.
Cables going everywhere.
This is ridiculous.
I've never seen so many wires.
Yeah, it is a bit of a mess, but you know, it's the best we can do right now. So I would like to recenter this. I'm going to zoom out here, and let's see if we can get this thing over. So we got down and over. Oops, wrong button. Okay. Whoops, too far. And I check one thing and gotta go back and check something else. All right, I hope you can see that. Yeah. Okay. Let's see. Oh, yep. Someone said Fort Worth Astronomical Society had an excellent picture of Neowise. You're welcome. That is mine. I actually took that picture this morning. So yeah. Let's do. How about? Oh, geez, where did I put it? Now I gotta remember where I put it. So, because I'm not gonna go to Reddit at the moment. Fine, whatever. Reddit.com, Fort Worth. Okay, Fort Worth subreddit. Real fast. On top. There we go. Let's look at it. So this is the image that I pulled off of my camera this morning. There we go. How's that?
That's the comet we were talking about earlier.
This is the comet. So this is Neowise. This is C2020 F3, I think it is, Neowise. So now, someone's going to correct me. If someone can remember, yeah, great. All right, yeah, everyone knows my Reddit handle now. Fine. I don't care. Not that much, at least. So anyway, it's not like you can't figure that out anyway, because I go ahead and post this onto the Reddit, onto the Fort Worth subreddit anyway too. Okay, so someone's going to correct me if someone can find out. I don't remember if Neowise is a Earthbound observatory program or if it is a new satellite that's doing the observing, but a lot of the comets that are found now, and especially a lot of the asteroids, they're done by automated surveys. So they're not always looking for a comet. They're looking for something else. Sometimes they're looking for asteroids. Sometimes they're looking at stars. Sometimes they're looking at the sun. They're doing solar observations like the, which one is it? Is it Helios? There are several now, and I can't keep track of them all. The stereo satellites. There we go. That's one of them for looking at the sun. So they're observing the sun 24/7. They're in orbits that don't exactly go around the Earth. For the stereo satellites, there's one that's ahead of the Earth and one that's behind the Earth, and they're all three of us are moving together in orbit. And they're able to get images of the sun basically in stereo. Two satellites taking pictures at the same time, hence the name. So a lot of times we see comets that fall into the sun from those satellites. And they're coming from the outer solar system, they're coming from the Oort cloud, and they're coming in on steep trajectories, and they just hit the sun, and they're gone. And we only see them right before they impact. And there's no indication on the sun itself where it'll... there's not an explosion on the sun where it hits. A comet nucleus is only a couple of miles wide. They're not typically very big. Neowise is supposed to be, I think, about 3 miles across. The actual hard nucleus, the dirty snowball. The comma, which is the cloud right there at the head. So in this case, the comma is just that bright spot right there. That can be a couple 100,000 to 1 million miles across. And it's just the outgassing from the comet. It's the water vapor just being boiled away by the heat of the sun. And the tail is all that material being pushed out by the solar wind. So the tail can be a couple of million or more miles long, and there have been comet tails 50 to, I think, almost 100 million miles long. So they're very large, they're very impressive, but they're very tenuous. So it's very, very thin, but it's enough there that it does reflect some of the light from the sun. Back in 1910, when Earth passed through Halley's Comet, when Earth passed through Halley's Comet's tail, there was a big panic because right before then, cyanide gas had been detected in the tail, in the stream. And so people were worried it's going to poison us. There's cyanide. So cyanide's going to permeate through the Earth's atmosphere, is going to kill everything. Well, there just wasn't very much of it. But that didn't stop people from selling comet pills that were reported to protect you from the effects of cyanide. Sorry?
This is in 1910?
This is 1910. And yeah, people were absolutely panicked about it. And they went ahead and spent the money on sugar pills to protect them from the comet.
How were they able to ascertain that? I mean, I understand that we have the technology nowadays.
Spectroscopy.
Okay.
So we do a lot of stuff remotely. Spectroscopy is one of the things that we can do. So what spectroscopy is, it's looking at the light that's reflected off of an object. And we'll actually talk about that later when it comes to asteroids. But in the case of the comet, what we're looking at is the tail here, and we get a lot of light right there from the comma. What we want to do is see, we take a telescope, we point it directly at the comet. We get the light from here, and we run it through a prism, or a diffraction grating now, and we split that light basically into a rainbow. By splitting into a rainbow and stretching it out as far as we can, what we look for is these dark lines in the rainbow. And those dark lines are absorption lines of various elements. And we know what pretty much all of them are now because we can actually experiment. So we can take, and the neat thing is, the way you do it is you actually excite the atoms and see what light it gives off, what particular frequencies. So the excitation and the absorption are going to be exactly the same at the same frequencies. So if you have, let's say, hydrogen gas. So we take hydrogen gas and we energize it to its first energy level for hydrogen alpha, and it gives off a very, very deep red color. And it has, along a very, very particular wavelength, and it has a very particular set of lines. there's a look to hydrogen alpha light. Well, if there's hydrogen being energized and absorbed, sorry, let me phrase that. If there's hydrogen in a cloud that's absorbing the energy, it will have those particular lines. Instead of being bright lines now, they're dark lines in this black body radiation. It's high school physics and optics and chemistry.
I missed that.
You don't remember that?
None of it.
No. We don't have time for this.
I saw
but
Armageddon though.
No, not even close.
I got that.
All right. So what we do with the comet is we take the light, we spread the light out into a spectrum, and we look at these dark lines, these bands. We can take those lines and then we analyze them, and we know, okay, these lines are for this element, these lines are for this element. And we know that when elements are combined, like cyanide, which is hydrogen, and now I blanked out. What is cyanide? Nitrogen and something else. Now I don't remember. Oh well. Cyanic, I don't remember. Now I've blanked out. Oh well. So we look at the gases. We can see hydrogen, we can see oxygen, we can see nitrogen, we can see carbon. And one of the reasons why we know that there's, we call comets dirty snowballs, is because there's hydrogen and oxygen for water, and then we have carbon, soot. So the comets themselves, they're kind of the surface isn't very bright. It's like a dark gray color, just dirty ice. But when the sunlight hits it, all that ice evaporates. So a couple of months ago, we were looking at oh shoot, now I blanked out for that one again. We were looking at another comet. I want to say it's Pan-STARRS, but I don't think it was. It was something else. Someone remind me what we were looking at last time, because I have blanked out. It's been a very, very long day. It is a very hot day, and my brain is starting to get fried.
Chris, with these comets, how many of these are in some type of orbital pattern that we keep getting a chance to observe? Is that typical of comets?
Lots. Almost every comet.
Really?
The only ones that don't, Moru-Ramu, whatever that one was that came in a couple years ago, that was an extrasolar comet. Okay. Came in, or possibly an asteroid. It came in and then it left. Okay. But its trajectory was hyperbolic to the point where it was definitely outside of the Oort cloud. It originated outside the Oort cloud. Stuff that originates in the Oort cloud. Where is the Oort cloud? How do we identify that? Oort cloud is a theoretical cloud of icy material that surrounds the solar system. Okay. So we have the Kuiper belt, which extends out from basically where Pluto is, edge of Neptune, Pluto, out further past, and then past the Kuiper belt we have the Oort cloud, O-O-R-T. And comets are thought to originate out in the Oort cloud. It is a remnant of early solar system formation. It's probably just a bunch of ice out there. And what happens is something disturbs these objects. So typically they do orbit in a circular orbit, roughly circular, maybe slightly elliptical, but relatively circular. Something has to interrupt it. There may actually be a Neptune-sized object out there that is causing some of these objects to slow down. Now, they're moving very slowly. It may take them a couple million years to orbit around. They're just very, very slow. The further out you are from the center of the orbit, the slower it can go in order to stay in the orbit. The closer in, the faster it's got to go. So it's far out. It's moving very slowly. It does not take a whole lot to perturb the orbit. Slow it down just a little bit, and then it starts to fall in, and then it'll go into an elliptical orbit. So we have these comets that have long periods. For example, Neowise has about a 7,000 year period that we've discovered, and we can calculate that just by looking at its orbit. Okay, orbital mechanics is relatively easy. Is that a cat?
Chris, does that mean that a cat? We won't be able to see this particular comet for another 7,000 years?
You won't.
You're right.
Yeah. Someone else will. I might.
Maybe.
No, I probably won't. So.
Robot Chris, maybe.
I'll upload my brain somewhere. So what happens is this comet comes in, does a loop, and then goes back out to its point of origin. Unless something disturbs its orbit as it comes close in, and then it may turn into a short period comet. So we do have a couple short period ones that come every couple of years, but they're not terribly bright. They're like little bitty fuzzballs. And in a lot of cases, they've lost a lot of their materials, so they're not very bright. And eventually they're just going to die. And by dying, I mean they're either going to fall into the sun, or all the stuff that can evaporate from them will evaporate from them, and then they'll just be like just a little hunk of leftover material. So all the ice will be evaporated, and you basically have, you know, dirt left, any rocky material. So it'll become an asteroid, essentially. Yeah, so that's comets in a nutshell. If you have any other questions, go ahead and ask. Camelback for my water. Yes, I have a Camelback. It is at home. It goes with the hiking gear, not necessarily with this. Bottled water is enough. I have plenty of bottled water, and usually tap would be fine, but we are down here in the country, so and we're in a pandemic, so I do actually have a Nalgene bottle, which I forgot to bring. I forgot to bring a lot of stuff. I actually forgot to bring a focuser. I'd send my cousin back to my house in Fort Worth to go bring my focuser back, because I totally forgot it. And we wouldn't be able to do anything without a focuser.
We could squint really hard.
No.
Not gonna work.
No, because it just won't focus. That's why we need a focuser. Right. Hydrogen gas, HCN. See, I knew, yeah, it was hydrogen, carbon, nitrogen. I knew nitrogen was there. I forgot about the carbon. So what? All right. Yeah, cats everywhere, dogs everywhere. And Comet Halley will be back in 2061, 2062. I do remember back in '86, I did not see it because I was a little kid, and my family wasn't terribly interested in astronomy, so we didn't really get to see it. I did see Hale Bopp, though, when it came by, and I remember showing it to my grandfather, so that was kind of neat. I remember it came in over the north, and we could see it naked eye. It was before I had a telescope, and it was quite neat. So, all right, that's going. Let's see if we can go to the live view. Jupiter's still in the middle. Okay, so we're a little bit higher. We're tracking. That's not too bad. Live mode. There's got to be a way I can set this thing up. There we go. Somewhat. So what we're looking at, so we have something over here. We got 1 Galilean, 1, 2, 3, and then we have the other one way up there. So let's find out what we're looking at. I'm going to go ahead and bring up Starry Night. It's an older version. It's fine. It still works. What I'm trying to do on here is figure out where I have my settings on here. I don't see where my settings are. What I can do is go directly to the camera and see if I can get that working.
Somebody wants to know if there's any good galaxies available right now.
There are probably quite a few galaxies. We will be looking at them. Yeah, if I can get this thing figured out. So, find it. Let's see if I can do it. Enter. No, I didn't really want to do that. Now I've got to redo this. Yeah, my alignment is way off. It's going to be one of those nights. Definitely going to be one of those nights. Jeez, that's going to suck. So, yeah, I accidentally ripped out the cable, and I don't know where it got. We're going to deal. Let's see, there it is. So, I've got my red dot here. Get it right back on here. Over. And usually we're doing this thing automatically. It's just not been terribly happy. Let's see, where is Starry Night? It's still coming up. It's not what I wanted. This is fun, isn't it?
Did the comment show up on the live video later?
No. So that photo that I took was actually at 5:45 this morning. And no, I'm not going to be here until 5:45 again. That's just a non-starter. I don't know of anyone who would really... Actually, no, I take that back. I know lots of people who would want to be here all night. I don't want to be here all night. I would much rather go home because it is hot. It is muggy. But here we go. So what I'm trying to do, I don't know how well this is going to work. I don't think this is going to work terribly well. So instead, I'm going to... man, I don't know how well this is going to work. Back. Line. Let me see if I can recenter here. Alignment status center. So my problem is... back. I'm going to have to do it this way. Align. Enter. I'm going to have to redo it. It's just not aligned right. Reset alignment. Enter resets. Align. Auto. We're just going to let it do its thing over again. So I have to realign the telescope so it is pointed at what it's supposed to be pointed at. It's just, yeah.
Well, Chris, while that's doing that, would this be a good time for you to tell me a little bit about the Astronomical Society?
So, the Fort Worth Astronomical Society. We've been around now 70 plus years. We've been about 71 years now, I think. And it was started by Miss Charlie Mary Noble. And she started a couple things. She actually started the Fort Worth Children's Museum, which eventually became the Fort Worth Museum of Science and History. And the planetarium, the Noble Planetarium at the museum, is named for her. She also started the a Children's Astronomical Society, and it was so popular that the adults wanted in themselves and kind of took over. So it became the Fort Worth Astronomical Society. All right, labels. Show all labels? No, we don't want to do show all labels. We want to do planets and moons. We want to do bright NGCs. And we want to do Messier objects.
Try not to throw Chris off by asking too many questions.
Not a problem at all.
With the Fort Worth Astronomical Society, do you guys get together periodically and do outreach events?
We used to. Yeah.
Well, what's going on nowadays?
Well, right now, not much of anything. We
got Star Party.
No more star parties. No more in-person star parties, I should say. But what we are doing is events like this. Whoops. Let's go ahead and center that. So we are doing events like this. We are doing virtual star parties. We're doing the virtual meetings. There's some other stuff that I want to do. There's some additional presentations I want to go ahead and put up online. And we used to do a whole lot of outreach. We would do museum events at the Fort Worth Museum of Science and History. We did events last year at various libraries, the Crowley Library, Irving Library. I believe there were several others. One of our big things was actually doing Tandy Hills. So Tandy Hills Natural Area is just to the east of downtown Fort Worth. If you're going on I-30 east, you'll see the broadcast antennas on the south side of the highway, right across from Gateway Park. And that is the Tandy Hills Natural Area. So we would do star parties there on the Saturday closest to the first quarter moon. Well, we've had to cancel those because there's not really an easy way to do this kind of stuff, to show this, at least the views through telescopes, in a hygienic manner.
So coronavirus has kind of put a shutdown
to
everything. Y'all are doing,
everything.
but it's not that Fort Worth Astronomical Society doesn't do these events anymore. It's that it's on hold for the time being.
Yes,
For foreseeable future.
until we have a vaccine, until we have something, we're probably not going to restart that. One of the options would be to have something like this, where we could have a telescope with cameras, with monitors that people could see. But again, the issue is, well, people are going to be crowding the monitors. Everyone wants a better view, and we can't really easily drag out a 65-inch TV to hook up to a computer so that people can see it from some distance away. So this is kind of our next best option.
So Chris, are you single-handedly driving the mission forward by yourself out here with all these bugs?
I don't have any frogs or chameleons, so yeah.
Oh, this is incredible. I'm glad that you guys are keeping it going. This is fascinating, and I was telling you earlier, it's a shame that things like this don't get more attention. Somehow we focus more at the end of our noses and our 40-hour-a-week job, and we never take the time to look up and forget that we're on this giant convertible spaceship.
The pale blue dot. So yeah, one of the issues that we have in the city is we can't easily see a lot of stars. We can't see we can see the planets, we can see the moon, we can see a couple of stars. We can't really see nebula. We can't see galaxies. In the fall, Andromeda is up high in the sky. We should be able to see Andromeda really, really well. From a dark sky site, you can see it naked eye without any issue. Andromeda is actually much, much bigger than the full moon. So if the full moon is about half a degree, it's about the width of your thumb at the, if you hold your hand out. So Andromeda is, I think, 6 thumb widths across for the whole thing. Even the center is a little bit more than a thumb width.
So are you saying 6 thumb widths away from the moon?
No, no, no. If you're seeing, so the Andromeda galaxy in the sky, if you could see it in its entirety, the way a camera sees it,
yeah,
it would be 6 thumb widths across.
So ridiculously.
It is rather large. There are several galaxies which are more than a thumb width across in the sky. They're a degree to 2 degrees across, but they're so dim that it's very difficult to see it naked eye unless you're in a very, very, very dark sky. And from the city, there's just no chance. We just have way, way too much light pollution, and especially in the center of the cities, where pretty much we are limited to the moon, the planets, and a couple of really bright objects.
So if we went far out West Texas, we'd be able to see it naked eye.
Depends where in West Texas.
Well,
now we have a lot of the gas
all
drilling in West Texas, so that ain't good. And yeah, so if that ain't good, we ain't seeing anything.
So where would be the best place?
Big Bend in Texas is probably one of the darkest skies you're going to find here. But you can find good places where you can see the Milky Way. For example, even down here in Grandview, we can see the Milky Way if it wasn't for the fact that I have really bright lights covered in bugs. Wow, that's a whole lot of bugs. I didn't think about that. That is just a whole lot of bugs. So bright lights are killing our night vision, so we just have a difficult time with seeing stuff. We actually have to go out to a place like this. So what I'm trying to do right now is just see what I'm seeing, and I'm seeing nothing. So let's see how close this is aligned. I'm going to go back to solar system. I'm going to hit Jupiter. I hope this is going to be close. If not, I'm going to be just... I can't believe I did that.
Bugging them out.
I really can't believe I did that. I can fix it, but I can't fix it right now. I need a good pair of tweezers, and I need my cable crimper, and I need to find out what the wire pattern is on this thing, because I ripped it out. All right, let's see. Are we on Jupiter? Are we live viewing Jupiter? No, we're probably way off again.
So Steve and Pam Candler said that they're, excuse me, said the monthly meetings together will return eventually.
Eventually, yes. We just don't know when. And oh man, it's way off.
Now, who all goes to these monthly meetings?
It's club members, and they're open to the public. So
Okay.
It's always, all the meetings are always open to the public. This is why even our virtual meetings, they are open to the public as well. We do it on YouTube Live once a month, as we have been. We're going to figure out what we're going to do for the meetings from now on, because we have a new president. And typically, I've been doing this from my house. So, yeah, because I've been doing it from my house, we've got to figure out what we're going to do. We haven't decided yet, but yeah, that's something we got to do. Select an alignment point and press enter, align,
So how does
enter.
somebody become a member of this prestigious organization?
Well, typically it would be at one of the meetings.
Yeah.
You pay your monies and you take your chances. We have a the family plan. I don't remember what it is. I believe the family plan is $60 a year, and that gives you access to our e-group. It gives you access to the dark sky sites. We actually have 2 dark sky sites. One is located north of Decatur, and the other one is located in north of Ranger.
What happens at these dark sky sites?
Well, we like to joke. There's a old joke where, for some of us with our wives, and when we tell our wives we're going out on a Saturday night, they're not really worried, because we're going out in the middle of a dark field with our telescopes and sitting out there very, very quietly, observing or taking pictures.
And not drinking, apparently.
Now, somebody may, but I'm not. Yeah, that's what we do. So we actually have telescopes at both locations. So you don't actually need to own your own telescope. You can actually use one of the telescopes out there. And there are people who go out there and just bring, food and water and a chair and table, and they drag out one of the telescopes there and just use that one.
That's cool. Now, are they all as impressive as the telescope system you're using tonight?
No, those are all going to be manual.
Yeah.
So,
that's good, because it doesn't look like I'd be able to operate that.
Manual telescopes are fine. This is going to be a really fun night.
Chris is very upset about that cable.
I'm pretty annoyed at myself, because I'm pretty sure that I kicked it out. It's dark, it's hard to see, so something happened. All right, I'm trying to redo the alignment. Accepted, up and right. To complete, up and right.
Steve and Pam Candler want to know if the new president is on tonight.
I don't know. Michelle, are you on? If you're on, please say hi.
Stand up and wave, please.
Well, no, something like that. So, yeah. Yeah, I'm kind of... one of the reasons why I do astrophotography is because my vision kind of went bad as well. So I actually had really bad eyesight, and I wore gas pyramidal hard lenses for a long time, contacts. And then I wanted to get LASIK, and I couldn't. So instead, I got the Visian implants, which were absolutely fantastic for the first couple of years. And then they gave me cataracts.
Oh.
So I had to get them taken out. And so I had cataract surgery first on one eye. Fun story, I didn't get enough anesthesia on there, so I was awake for the first surgery and got to see it from the other side.
Oh my god.
That wasn't that bad.
That sounds terrible. I had LASIK, so just that procedure was enough to... I'll never do anything like that again. I mean, it's incredible for what it did, but I mean, I could smell stuff burning.
Yeah, I didn't have that. They cut holes in my eyes. They pulled out the lens the first time, or they pulled out the lens. Then they destroy the lens inside, and then they replace it. So that was fun. So for the second surgery, I asked, please, can you give me some more, because I was awake the first time, and they were rather surprised.
Do you think 100 years from now, people are going to look back at that and see it as barbaric?
Oh, probably.
Drilling holes in the skull to relieve migraines?
Oh, yeah. I'm actually hoping within my lifetime I could get a new set of eyes cloned. eventually. So these are actually reading glasses, and I just need them to read. I actually had the choice of up close vision or distance vision, and I actually chose the distance vision because of astronomy. I wanted to be able to see the night sky naked eye without having to use glasses, without any corrective lenses. Even though I do my work on a computer, even though I do most of my work up close, I wanted that distance vision. And some people opt for close vision with one eye and distance with the other, and that can cause headaches. I just didn't want to mess with that. So I can do distance vision now, and it's a little bit better, but it's still an issue, and this is why I do astrophotography. So, or at least I'm trying to. This thing isn't making it easy.
Doing great.
This isn't making it easy at all. So here's what we're going to do instead. I'm going to say nuts to this, at least temporarily, and I'm going to see if we can get this thing up and running. Because I should be able to see something. I should be able to see something, and I'm not seeing anything. So what I'm trying to do right now is I have a camera on here, and this is a guide camera. What the guide camera does is I should be able to lock onto a target star, and focus. My problem is, why can't I see anything? I don't know why I can't see anything, so we'll get this out of the way. I actually have this is a field reducer. I thought, hey, maybe if I try a wider angle, well, that's not working. Obviously, that's not working.
Lens cap?
Sorry?
Joke. Lens cap?
No, I took the lens cap off. Thank you very much.
Hey, that's my contribution.
So I should be able to see a white dot there. Why am I not seeing a white dot there? Camera's all connected. Oh, man. This has been a fun night. I probably should have stayed home.
We're glad you came out.
I don't know.
Bugs are glad we came out too.
Is that moving? That's not moving. It's a 2-second exposure. I should be getting something, and I'm not getting anything. Alright, here's what I'm going to do. I'm going to go get a different camera. It's around here somewhere.
I'll read comments.
What do we got for comments?
Let me see here. I saw something about a detached retina earlier. So, Michelle is not on. She is out at the dark sky site. Prius 357 says that she had new lenses, both eyes. Worked great for a year. Retina detached. There's a word I cannot pronounce. Sounds like it did not end well. Matt Frost. Where is the location north of Ranger?
It is near La Casa. I think that's what the town is. It is pretty much in the middle of nowhere. It is not actually in a town. It's off somewhere. So I'm gonna
Very remote.
stick this thing in here. This thing is not going to be running right now. I have another DSLR.
Fort Wayne Astronomical Society, Indiana. We're hoping to get a telescope live stream going as well, since we can't offer stargazing nights right now.
Yeah.
So,
Yeah, it's not terribly fun. And doing this is not a whole lot of fun either. And why am I missing cables?
it's something I wouldn't have thought of until I met Chris, and there's going to be a lot of stuff that comes out later on after we get out of troubled waters with the coronavirus. But there's little bits and pieces of stories coming out right now that are just astonishing. But months down the road, years down the road, we'll have a full idea of everybody that was affected by that. But something to think about. Astronomical societies probably worldwide are affected just like everything else.
Yep, there's lots of groups that are wanting to do events and they just can't.
Yeah.
Just kind of stuck.
But like Fort Worth Astronomical Society, people are adapting and finding ways around it. So
We're trying. In the meantime, I swear, if it's not one thing, it's another.
Chris, we're all rooting for you, man. You're doing
I'm trying. So what I'm trying to find is cables and an adapter. I know where my adapter is now. I don't know where my cables are.
He's got half of what he needs, folks.
It's just kind of a comedy of errors right now.
You're halfway there. Full faith in you. It's a perfect night for this, not too hot. If these bugs weren't here, it'd be great.
So
Hardly any wind.
Jupiter's up. We're going to be doing something in just a bit. We're definitely going to be doing something. I'm not gonna bow out.
Chris
just because
is a show must go on kind of guy. Looks like
it better. All right, so we got that. We got that.
And I'm a helper. I desperately want to help, but there is nothing I can do over there.
Nope, I'm afraid not. This is on me. Alright. That's actually working. But it's not aligned where I want it to be. Definitely not where I want it to be. So I'm going to, let's go to the camera here. Rescan for cameras. Whatever. I want to do that one. I want to do 100%. I just don't see anything.
Does that mean it's probably off center from your target, or?
Probably. Let's look at this one. Where is I'm not getting eaten alive. Is just not pleasant right now.
We're all having dinner over here, Chris.
Oh. So what do I want to do here? I've got to figure out how to get this thing going. It's manual. I don't want bulb. I thought I could change everything through here. Oh, there it goes. There it goes. This is what I want. Not bulb. Here we go. Let's knock this down. Now we can hopefully get some details on Jupiter. I want something a lot smaller, a lot better. We're going to do shooting menu. We're going to do live view. There's Jupiter. All right. Because here's what I want to do. There's Jupiter. There's live view. Let's see if I can get this thing down. I want it dim, 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 dim. So we're barely able to see those moons. Because I want to see this. There we go. There we go. So you can see it's kind of still. There we go. So it is still actually fairly wobbly, but we are getting some details. I've got bugs in my hair. It's just, I should probably be filming this in the dark, like a mushroom. That's probably the best thing to do. On the plus side, I am not getting eaten. I'm just covered in bugs. I have no mosquitoes. Apparently, I taste disgusting to mosquitoes.
I'm O positive. Maybe that's what they're into tonight.
That could be. So what are we looking at? We're looking at Jupiter. The moons have gone away. Why have the moons gone away on Jupiter? Well, they've gone away because we are shooting very, very fast. Our exposure is very, very short. So we can see some of the detail on Jupiter. So what we can see here, we can see some banding. And if we jump to Starry Night, let's see, I want to zoom in on Jupiter. Looks like the Great Red Spot is over on the edge, so we're probably not going to be able to see that terribly well. That's okay.
That image that you have on your screen right now, that's coming off of your scope?
No, this image right now, this is Starry Night Pro. This is an application that normally I would use to control my telescope. Yeah, that's not happening right now. Oh. So, yeah. Normally I'd be able just to control it. I could do some syncing. Everything would go swimmingly. It'd be really fantastic. And it ain't happening right now. It is what it is. Okay, so, geez. All right. I'm going to have to do some realignment, recentering. But for now, we can just go back to Jupiter. Here we go. Zoom view. So we can see, I wish I could get this thing a little bit bigger, but I can't. I think that's all it can do. Fit in window. Fit in window. Is that bigger? No, that's all it does. Okay. That's his... They're not very tasty.
Get some comedy clips out of this anyway. Spoof reels.
Okay, so we're looking at Jupiter. From the view, the great red spot should be right here on the edge. What we can see is the banding that goes across it, and that's about all that we can see. Let me see if I can make it a little bit darker. It's not what I want. It's not what I want. This is what I want here. It's not what I want either. Zoom view, and I want, there we go. So this makes it a little bit faster. And what I'm trying to do is see if we can get a little bit more detail out of it. Sometimes you want it brighter, sometimes you want it dimmer. So I think about 1,000 is fine. We can see some of the banding on it, not terribly a whole lot. This telescope is not meant for looking at planets like this. It is really a wide field telescope, but it'll still do planets just fine. So it actually looks halfway decent. Flew into my ear. It did fly out, so that's a plus. So what I'm going to do right now is get a little bit brighter, and now at the point where we can see the moons, we can no longer see the banding. So Jupiter is pretty much blown out. But I want to take a bit longer of an image so we can see some of the stuff that comes out. We want to be able to see 1, 2, 3, and 4. So let's compare it to Starry Night. And zoom out. Come on. So what do we see? We see, what is this? This would be a star. So that is not a moon, that is a star. It's going to be hard. So we have Io and Europa. Let's go back to zoom view. We have Io and Europa. Is that it? Io and Europa. Sorry. Io is out. Europa is in. Even though Io is the closest of the Galilean moons to Jupiter. So this is probably at the extent of its orbit. And Europa is either close or on the other side of Jupiter. And then over here we have Ganymede and Callisto. And so this is not actually, this would be a star out there. Let's just recenter. Center on Jupiter. Zoom out. So Ganymede and Callisto are way out. So let's do this. Let's look at that zoom view. So this is a star, not Ganymede or Callisto. Here we go. Actually, that could be Ganymede and Callisto right there. Actually, those probably are, because they are round. They're not points like a star is. Yeah. These, I think that red dot is probably just a hot pixel on there. I don't think it's any object. Could be. So we're looking at the Galileans, and that would be a star right there. It's twinkling. These guys are fairly solid. They're not twinkling. So that's one way we can tell what is a planet and what is not. Planets don't twinkle. Stars twinkle. Because a star, because it's so far away, it is essentially a point of light. So now, so we've seen Jupiter. There's not a whole lot to see right now. It's still pretty low on the horizon. I'm going to swing us over onto Saturn.
So what's the difference? I understand the difference between a star and a planet, but why does it twinkle?
So, a point light.
Okay.
Point light is going to be... The star is so far away that all the light that comes from it is essentially parallel. Because it's parallel, it appears as a point source of light to us for most stars. Some of the larger ones, Betelgeuse, in Orion, and several others, we've actually been able to resolve the surfaces of them, which means we can see them as a disk with a big enough telescope. With some special technology, we're actually able to see the surface of Betelgeuse with some resolution. But essentially, mathematically, we can just say, yeah, stars are point objects. Because it's a point object, because all the light travels from that object to us in a parallel line, as it goes through the atmosphere is moving. there's wind up high, there's temperature differences, there's gradients, you have basically thermoclines, where as the light goes through that layer, it's refracted. So it moves a little bit up, moves a little bit down, just like it would through water. Like the water-air interface, it gets refracted, it gets bent. So what we're seeing is the bending of the light. Now, there's a really, really neat trick that a lot of big telescopes use. And what they have, like on this one, the mirror on the back of the black telescope here, it's fixed. Now, it expands and contracts a little bit depending on the temperature, but it's a fixed mirror, it doesn't move. The big telescopes, they actually have fairly thin mirrors with motor actuators underneath. And they don't move very much, thousandths of an inch or less. But these motorized actuators are all controlled from a computer. And the trick is this. You need an artificial star. You need a star as a guide to see what is the atmosphere doing. So these are laser. They literally shine a laser up at the sky, close to where they're observing, and they look at the light reflected, the laser light reflected from the atmosphere, and they see how it moves. And so there's a very, very, very fast camera that's watching that, and it's taking those motions and it's translating them into motion for the mirror. The mirror is actually being flexed. So this actuator may push up, this one may pull down, this one may push up in this direction. So the whole mirror is kind of moving back and forth and back and forth. Uh-oh. Oh, well, we're having some issues, some tech issues. We'll see how that goes. Oh, man. Yeah, we're getting some tech issues. We'll see how this goes, but all right, we'll see. We have no wind here, so the bugs are staying right with us.
Every one of them.
Every one of them. So where was it? Okay, so the mirror is actually being actuated. It's flexing, and it's flexing in order to stabilize that artificial star. Because once the artificial star is stabilized, every other star is going to be stabilized too. So that laser acts as a control. The camera sees what the laser is doing in the sky, and then the mirror or the actuators are trained to move it. So like if the image from the laser looks like this, like a elongated blob in this direction, well, flex the mirror in this direction. And they keep testing and testing and testing until they get it right. And then they just flip it on and go. And it really stabilizes the images. So you can get rid of a lot of this atmospheric effect, what we're seeing here, by flexing that mirror. It is not cost effective to do that for a mirror of this size, but if you have a mirror that's 10 meters across or bigger, yeah, you want to get the best images you can, so it does become effective. Where do you think you're going?
I gotta get some air duster.
Oh, yeah, this is hundreds. Wow, this is hundreds. Okay, so this is a light-colored table. So all these bugs are covering a light-colored table. There are hundreds of these things. I don't even know what they are. They're these little black bugs. On the plus side, they're not doing anything. They're just sitting there. But on the bottom side, some of them are flying up and hitting me in the face. So, acquiring the image. Yeah, I'm still trying to do my alignment. I'm trying to see. I just want it aligned. Acquire 28 stars. So what I have on here, it's a Celestron StarSense. It's a neat little device when it works. And what it does is it's a little camera, and it takes a picture of the sky at a particular location and does what's called a plate solve. And what a plate solve is, it looks at all the stars and then figures out what it's looking at, what constellation, what stars it's looking at, and then it's supposed to tell me, oh yeah, yeah, I know where you are. Up and to the right, huh? All right, let's see what that does. Enter, acquiring image. Let's see what it does. yeah, I don't know what it's doing. We'll go back to here. So I haven't moved it much, but what I really want to do is recenter that thing out so I can see it in here. And I don't know why I'm not seeing anything in here. Maybe I'm not doing something right. Maybe I don't know. I really thought I had this thing set up right. I guess maybe I don't. It should be RGB 24. Yep, maximum resolution. I'm not doing anything special. There's no binning. I don't know. I don't know what I'm doing wrong right now.
So is it just scopes out? Or is it the software?
I don't know. Oh
man, that's gotta be frustrating.
It is. Yeah. So I want to see if I can get anything. Maybe I want to change to a higher bit depth. Yes, I do want to do a higher bit depth. RAW 8. I'm doing this. RGB 24. RAW 16? I don't know anymore. Yes, whatever.
Sasquatch 6160 had some great advice. If you wear your mask, you might not eat so many bugs.
Oh, they're not flying into my mouth, they're flying into my ears. Position, complete centering, what does it say?
Looks like they're having some trouble with my bad night sky.
Press enter. Yeah.
Sasquatch says if we lay a white sheet over a chair about 10 feet away, should block the mosquitoes.
A white sheet?
Mm-hmm.
Really? Now?
Bugs will
today?
That
a white sheet?
Alone. Makes sense.
Yeah.
They reflect light.
Except that we have a white table. So.
And I'm white as a sheet. I'm wearing shorts, so white legs are out.
Yeah, I went with
that sheet would have some competition.
With dark, so nonetheless, yeah, we got white table. That's
well, Chris, I'll tell you what. While you're working on issues there, I've got bugs literally crawling into my interface, so I'm going to go ahead and pack this up. Before I kill the recording for Fort Worth Roots, is there any other information you want to put out for Fort Worth Astronomical Society?
That's a good question. Right now we're kind of stuck in a holding pattern. We're not. I'm working on the website. I've been working on the website for a while, and it's one of those where the plumber doesn't fix his own pipes. I mean, sometimes the last thing I want to do when I come home is, or let me rephrase that, because I'm working from home. Once I'm done for the day, the last thing I want to do is go back to my computer and work on other stuff. So it's slow going, but once I have it complete, once I have it moved over to the new platform, there will be a way to sign up for the club online, pay your dues, pass your information, and we'll be able to get you set up fairly quickly. But yeah, and hopefully I'm going to get that done in the next couple of weeks. I want to get done before the next meeting, but I've been saying that for a while, so I can't really promise. Yeah, I will do the best I can on getting that ready. What else about the club? So when we are able to have monthly meetings again, that will be nice. When we're able to do outreach events, that will be nice as well. One of the things that I do miss is actually going out with the meteorites and showing off the meteorites. So people who have tuned in on previous broadcasts, I have brought out the meteorites before, and it's kind of neat. You get to hold a piece of space in your hand. I have Martian rock, I have lunar meteorite. So what I like to do is you take the moon rock and you put it in like a little kid's hand, and you say, "Can you guess where this is from?" And it's like, "No." And you tell the parents, "Go get your phone ready, take a picture." And then when they're taking the picture, you tell them it's a rock from the moon, and their faces just light up. It's really nice.
Awesome.
And NASA doesn't let you hold their moon rocks. they all have them locked away. Now, if you go down to Houston, they have a lunar rock which is embedded in lucite, a plastic, and then it's got a lucite kind of cover on it as well. So what you do is, if you want to touch it, you stick your hand in and you kind of go up and then over, and you can take your finger and you can just barely rub it. So probably millions of people have rubbed it. It's just a black rock, little triangular piece of rock now, covered in everybody's oils and germs and kind of worn smooth. So not the greatest of things.
I have to check that out for sure. You were showing me over a Zoom meeting we did all your, well, some of your collection, and
oh yeah,
you got some excellent exhibits there. On the comments, Edward Fries was asking, how can we become a member?
That's what we just talked about.
Yeah.
Is I will have that. So we will have, we typically do PayPal or mailing in a check. PayPal is just easier for everyone. So we will have that set up, and as soon as that's ready, I'll go ahead and post it to the Facebook site, and I will post, and well, it'll be on the new website. So we'll make it really obvious. We'll make it really easy to sign up.
And they can just go to Facebook and look for Fort Worth Astronomical Society, and it pulls right up.
Facebook.com/Fort Worth Astro.
Okay.
Yeah, that's easy enough.
And website?
FortWorthAstro.com.
Perfect.
And .org.
All right. Well, Fort Worth Astronomical Society. Thank y'all for letting me tag along with Chris.
You want to stay longer?
I'll stay with you, but I want to go ahead and put up this interface because
oh yeah,
I went and got the air duster and I was trying to blow them out, and they're
that's just not going to happen.
Seeking refuge inside my brand new toy. So
yeah, it's there's just so many bugs.
If y'all have any questions for me, you can reach me at media@fortworthroots.com. Happy to answer any questions. And like I said, we'll be going live 20 July here in a little over a week. So, Chris, thank you again, man. I really appreciate it.
So, no worries.
Yeah, like I said, I'll stick around for a minute, but I'll go ahead and end this on the Fort Worth Roots side. Thank everybody for listening, and we'll see you for the next episode. Bye.
All right, I'm going to keep the camera on you just because it's too much of a pain to change it. So I'm going to keep trying to get this. Yeah, sleep is overrated. Yeah, no kidding. So again, I was up at 5 o'clock this morning taking images of the comet. So yeah, I don't know what is going on here. I really have no clue. So what I'm going to do is cry. I'm gonna have a good cry. I think that's what I need to do. I just need to have a really nice cry.
Are you rethinking the no alcohol rule?
I don't have any alcohol.
Well, you said you did.
No, I have water.
Oh,
what I have is isopropyl alcohol for cleaning my hands.
Desperate times.
No, no one should be that desperate. Isopropyl alcohol is not the way to go. So again, I don't know what's going on here. I really don't know. I've been, I've had this thing working before, and it's worked just fine, but something is just not right. So, yeah, I'm not able to actually see anything on here, which is just ridiculous. And my alignment's not working. I'm just not having a good night. So, I'm not going to quit. I'm not giving up. So, I'm going to keep on going. All right, this is less than fun. Let's see if we can see Saturn. So, nuts to this. It's still plate solving. I swear, this is... We may have to go back to first principles and do it that way. Yeah, I think I'm going to have to go to first principles. But in the meantime, let's just go ahead and look at Saturn. Okay, so Saturn is, if I could see it, there we go. Saturn is just below and to the left of Jupiter. Wrong direction, right direction, wrong direction, and right direction. Where is that red dot? You're looking for the red dot. And you're looking at this side. So I have to take my reading glasses off while I do this. That should be close. Do you see Saturn there? There's Saturn. Alright. So we're going to go a bit slower. You know, the funny thing is, I actually tested this thing out this morning, and it was actually working. So, yay me. All right, cool. So let's do it again. That is Saturn. Is that cool or what? Yeah, it's not that cool. It is way, way, way too fast. So let's go ahead and slow that down. Live view. Here we go. What is that? That's a June bug. All right, here we go. So we got 1/5 of a second. We need a lot faster than that. There we go. Oh yeah, there we go. Now we can see some rings. That's not too bad. Now I'm going to zoom out again because I want to make sure this is centered. Yeah. So I'm going to kill this display mode. So I want this relatively centered. I want this down here because I'm going to try, I'm going to try to get this thing where I want it for the other camera. Oh, there we go.
Everything come up?
That's what I want to see. What do we see here? We see an out of focus image of Saturn. And what's really neat is we can see the spider, the structure that actually holds up the mirror in front of this telescope. So, let's see. Which direction do I want? There, that's the direction I want. It is still an out of focus image of Saturn. Okay, which means I need a barrel extension. So, grab that. There, grab that here. Fiddle with that. And that is now way out of focus. Good, let's bring that in. Please reach focus. I don't have that far to go. Almost there. Almost. Just about. Okay. Gonna do a couple things. One, move this. Wrong direction. Right direction. We're gonna have to play with it as we go. So this is much too long of an exposure. Way too long. So instead, switch from LX mode. We're going to bring this way down. Oh man, what does that look like? That's an out of focus Saturn. Kind of weird looking, isn't it? Let's get that in focus, but that's not too bad for time. Alright. So I have a fine focus on the other side. That's getting there. That's getting there. Let's see if we can see any moons. We can focus on the moons. I don't see anything. Let's grab this direction. That's back out of focus. What I really could use is a good autofocus, or a, what do you call it, moto focus for this thing. Unfortunately, I do not have one. So instead, 100%, let's go to, not 40%, wrong direction, 200%. More bugs. So, let's get a little bit better. Is that better? Is that worse? That's worse. Focusing is so finicky sometimes. Yeah, I'm not sure I'll be able to get it much better. It is still pretty low in the sky. And I'll get a little bit higher. But what we can see, can make a little bit of banding that comes in. Do see separation. So if I can get a little bit faster. There we go. Yeah, it's still kind of wonky. I want to see if I can pick up any moons. Every once in a while we can. Let's look out here. I don't see anything. I don't see anything. I don't see anything out here. Maybe if it was over there. Oops, wrong direction.
So Chris, what's different between the method you're using now and what you were trying to accomplish earlier?
Oh, this is a totally different camera.
Okay.
Yeah.
So
And
it's still, you're still using the computer to move everything around, but it's
I mean, you mean
different camera.
the handheld? I'm using this thing.
Okay.
Yep.
So just.
Yep. So yeah, it's kind of hard to see, but there we go. So yeah, why is this? Sorry, I had no idea. Oh no, that's fine. That's fine. Okay. So what we can see is a little bit of banding's kind of hard to see. Yeah, it's just not a great night. It's a still night. It's just not a very good night to do some of this observing. The atmosphere's just moving, and it's not the telescope. This is actually the atmosphere. So it's just not a stable atmosphere tonight. We're not having that great of luck. I'm not going to be able to get much of a better focus on Saturn. It's a little bit lower than Jupiter, but man, that's just, that's just ugly. I gotta say that's just an ugly image, and it's not the focus. I've got the focus pretty decent. Is just so much. Oops, wrong direction again. It's just so much atmospheric movement. So if I'm looking at it right now, yeah, it's about 15 degrees up, a little bit less than 15 degrees. So it's still pretty low in the sky, and it's just not pretty right now. Yeah, we're not going to get decent images out of it. Oh man. Well, tonight's not turning out to be as nice as I had hoped. But that's okay. We can do some other things. I'm thinking stars. You know what? I may have to do. Yeah. Oh, geez. Let me do this. I'm going to be looking up. I want to see what we can see right now. With these bright lights, it's really, really hard to see. I mean, it is. I just can't see anything. I can see Jupiter, I can see Saturn. I've got nothing else. No, wait, I got a couple things. Okay, so we've got the summer triangle. Yeah, we have Deneb, Vega, and there's Altair. I can see Altair. I do see Deneb. I see Vega. Altair should be over there. Probably over there somewhere. So we do have the summer triangle out. We can see some stuff in there. I'm going to have to figure out some other alignment here. Alignment set, add alignment reference, and then select alignment point. All right, so I'm gonna try to do another alignment here. Something's not right with my system. I'm not sure what it is. I don't think I changed anything, but it's just not running the way it should be. So what I'm going to do is I'm going to wait for that to stop. I'm going to align it on, let's see, what is it? Oh, there it is. There's Altair. Or Vega. There's Altair, Deneb, and Vega. With the lights, I have no night vision whatsoever. So, no night vision is a bit of an issue. I bet this is kind of boring right now, because I think it's kind of boring. But, gotta get done. Alright, what is it? There it is. So I'm going to be swinging this over and taking another image. So I got something right there. Let's see what we're looking at. I want to get a star in there. I may have to go wide angle. There we go. We got a star. So here's what I want to see. This would be, oops. If you can barely see that, let's make that faster. And this will also help with focusing. So I'm going to make this slower, I should say. Make that star a lot brighter. There we go. There we go. 2-second exposure, roughly, and zoom in again. So now we have a star. It's relatively nice. It's round. You know, I still have that camera on you.
Yeah.
On your elbow.
You want it off, or?
No, it's fine.
Okay.
You still gonna sit, or?
Well, I put up my seat.
Oh, if you'd like, there's a seat. If you want to go back around, there's a chair. You can use that one. I'll burn it after.
Right.
Okay, so we're looking at a star. We have Vega. So this would be. Let's see what it is. Let's go to Starry Night Pro. Because my brain is fried today. I remember nothing. I know nothing. We're looking towards the east. Turn on labels for stars. That's who we're looking at. Deneb, Vega, Altair. We're looking at Deneb right now. Ooh, we can look at North American Nebula. That's neat. Maybe we could do that. Alright, so here's North American Nebula. We can get Deneb. Maybe you'll do North American. Point and press enter. Okay, acquiring image. I don't know what it's going to do right now. We'll see. So, North American Nebula. North American Nebula is pretty nifty. It is a very large nebula. So, what we're looking at right now is a field of view indicator. So the neat thing about this is this will show 1 degree and 2 degrees. There's a finder called a Telrad, and it makes it really easy to go star hopping. So it gives 2 red rings that you can use to go from star to star. And in this case, we have a 1 degree ring, we have a 2 degree ring. The full moon is a half a degree. So the full moon is this big. So the North American Nebula takes up a large part of the sky relatively, but it has such a low surface brightness that it's very, very difficult to see. So we're going to just try to do something. I don't know how well this is going to work because I don't have guiding going on. I got nothing. But we're going to try to do this 100%. So we got a star here. I'm going to recenter this thing. Enter to accept.
Are you aiming for that nebula that you were just showing off?
I'm about to. It's Texas, so I'm fixing to. Yeah, this isn't fun. So I don't know what's wrong with this thing. I really don't. I would say I really want to burn this thing down right now.
Is it the new motor that you had brought out?
No, I don't have a new motor.
What was the device from that got brought out?
Which device?
Emergency delivery from Fort
Oh, that was a focuser.
Focuser.
Yeah, I totally left my focuser at home. No, that's the focuser. The focuser is just fine. It's something else going on. So let's get back to here so I can recenter this thing. There it is. Oh, it's way off still. Okay. I just did this. Something's not right with it. Alright. So here's what we're going to do. Acquired 81 stars. I swear, this thing should know what it's pointed at. So, next, solving. It's doing a plate solve. It's doing its thing. All right. No questions. All right. So I'm. Okay, we're gonna do stars. Named. Enter. We're gonna do Denab. So what I'm gonna try to do is something else. Okay, next time it's gonna be better. Next time it's gonna be for my house. And Denab. Enter. All right. This thing better be pointed at the right location.
Are you loading presets?
No. No, this already has the stars in it.
Oh,
It
okay.
knows what it's supposed to be looking at. The problem is it's not pointed at what it should be pointed at.
Oh, okay. So it's zero. It's not zeroed.
Essentially. We'll have to figure out why it's not. It's not. Okay. Here's what we're going to do. Motor 5. It's still not pointing where it should be. It's saying, oh, I'm pointed over here, but it's not. It's, yeah. It's close. It's close, but it's not. This is centered. And what I want to do is I want to say, hey, stupid, this is now centered. And it's not letting me do that.
Is it doing micro adjustments trying to find its...
No, it's not that smart.
Okay.
No, what I want to do is right now, that bright deal right in the center, I want it to say, hey, this is now centered. And you can see it in the other image.
This whole
Here.
setup is fascinating to me. So the tripod is communicating with everything. The computer...
No, the
cameras.
tripod just sits there. Tripod does nothing. It just holds everything up.
What's doing all the smart stuff then?
Oh, well. That would be the mount.
Ah.
So you have, see, now this is centered. You have the mount and you have the tripod, which are two totally separate things. So this, I want to say it's centered now. So what I should do, Denab, align, calibrate center, hit enter, then course centering, it's centered, fine centering, it's centered. Fine centering, yes. Align, capturing image. Now it should do it. I think I got it now. If not, I'm gonna cry. That's what I'm gonna do. I'm gonna cry. Okay, so it's acquired 90 stars. That's amazing. I can see 90 stars when I can see one. So it took an image. It's doing the plate solve. It's finding where it is, and now it should say, yes, I know where we are. And now, once this is done, enter accepts. The new center reference has been saved. Telescope will now need to be realigned to take geez, enter. Are you serious? It wants to do another align. Quick align, let's just do quick align, enter. Send alignment to, no, back. Auto, we're just going to do auto align again and see what it does. But at least it got a center. So it knows where the center is in the image. That probably better. You know, today I actually thought about shaving my head. And that way I wouldn't have bugs hiding in it, but it would be highly reflective, and I would instead have a hair of bugs. So either way, it's not a fun thing. Hundreds of them. Oh, and they're not on the black stuff. They tend not to be on the black stuff. They're just on the white stuff on the table.
Work?
Maybe, but we need like a huge sheet out here with floodlights, and that's not going to help either. So we're kind of stuck where we are. All right. So what are we doing now? We're doing another alignment. Shouldn't take too long. It'll do its thing. So let's talk about the nebula. So I'm going to get this on North American. Actually, you know what? Let's do this. Let's see what else is visible. Last time we were looking at... Not what I wanted. Last time we were looking at... what? We're looking in the Milky Way. So... Oh, it's Jupiter So we're looking at some of the Trojans and the Greeks. So here we go. We were looking at the Lagoon last time. So here is the summer Milky Way. So we're looking at the Trifid, and we're looking at the Lagoon, so we can do that again. These are some of the brighter ones. We can look at the Omega and the Eagle Nebula. I think we looked at the Eagle, not necessarily I don't think we looked at Omega, but I know we looked at Eagle. And we have the Sagittarius star cloud, which is a remnant of a galaxy. We've got a lot of interesting stuff in here we can look at. Here's an M23. This is an open cluster. We've got lots of clusters, Ptolemy's cluster, but these are further down. We have Antares, the blood red heart of Scorpio. Lots of stuff around there. We have M4, which is a globular, so we can get into that, assuming this alignment works. I'm really hoping it does, because I want to do some more stuff. A coat hanger. Oh, that's kind of neat. The coat hanger is Brocchi's cluster. This is kind of neat. I'll just show you here. Why is it called a coat hanger? Because it kind of looks like a coat hanger. There's a line of stars across here, and then there's a hook. So it's called a coat hanger. And it's really, really visible as soon as you see it through the telescope. Alignment failed. Not good enough. What? Let's try this again. Once more with feeling. Otherwise, I'll have to figure something else out. This is getting ridiculous. It's just way off. So, let's talk about North American. Actually, there's a bunch of nebula around here. So, North American Nebula. I know, I'm going really, really fast. Hopefully, I won't get seasick or dizzy, whatever, space sick. So, the North American Nebula. This is an emission nebula. It's a very dim nebula. It's very dim surface brightness. It is reddish. So, when we take images of this, we typically do this in hydrogen alpha light. And you have to have a camera that is sensitive to this deep, deep red color. It's very close to being infrared. So our eyes do not see this well. Even if you have a fairly large telescope and you're looking at the North American Nebula, it is still very, very dim. You just see a little bit of it. So instead, we do stuff like this. Jeez. Let's see.
What makes it an emissions nebula?
What happens is you have gases. Geez, really? All right. So the hydrogen gas in there, new images. The hydrogen gas in there is being lit up by stars. I'm gonna go with. Where are my images? I don't remember. Yeah, I probably shouldn't be doing this. That's fine. There we go. Here we go. This is a good one. So we're going to do this. Open new window. There we are. This is an image I took a couple years ago of the North American Nebula and the Pelican. This is it's actually a mosaic. This is so big I had to take multiple images and stitch it all together. But what you see is this is just hydrogen alpha light, and it's in black and white because if it was red, you really couldn't see a lot of the details. Our eyes just aren't that sensitive to red. There's kind of
that's not its true color.
No. It's just a deep, deep red color. And the funny thing is, for the nebula, if you were in a spaceship really close to it, you still could barely see it. Yeah. There's not a whole lot of light that's coming from it. This image took, I think this was 10-minute exposures and several dozen images. So you just keep taking exposure after exposure after exposure. The longer the exposure, the brighter the image is going to be. But the more risk you have that a satellite's going to pass through, or that it's going to get jittered.
Keep the aperture open for 10 minutes.
It's just
because we're moving. So
Oh, so the mount tracks with the night sky.
wow, that's a
And when you have a guide camera like I was supposed to have on here, trying to get it working. Oh, there we go. Enter. Fine. The guide star. Let's go there. See if that works. Sorry, let me rephrase that. So we have a guide camera, and then that locks onto a star. You train the system to keep that star on this one pixel and don't move it. Okay, so if the star starts to slide over, it'll push the telescope back.
But it's able to do it so quickly that you're able to maintain that level of quality.
Yep.
That's amazing.
And the more expensive the mount that you have, the better it's going to be able to track even without guiding. There are several mounts that will do 20-minute unguided exposures, which is nice. But this ain't one of them. Okay, so I should be on Denab. $5 says it's not. Well, I lost that bet.
You got it?
Got it.
That's a good one to lose.
That's Denab. All right. So at least it's on Denab. So here's what we're going to do. We're going to go Starry Night. This is NGC 7000. So we're going to do Deep Sky. Back. Deep Sky. We're going to go to NGC. Enter. We're going to do 7000. 1, 2, 3. Enter. It should move it slightly down and a little bit back up. It just does it that way. I don't know why. So we're going to be on the North American. And when we look at it in here, there's nothing, which is fine. So instead, we're going to do this. We're going to get rid of the zoom view. Oh, we got some stars. That's fine. We're going to get out of that. And instead, we're going to take an exposure. Manual exposure. 2 seconds? No. We should take a much longer exposure. It says bulb, but so I'm not doing any guiding. I'm not going to mess with it right now. We'll see how well this works.
How long of an exposure?
Let's start for 30 seconds.
Have it open manually right now?
Yeah.
Okay.
Let's start for 30 seconds, and we'll go from there. I've taken exposures with this camera up to, I think, 20 minutes. It's not a great idea to do, but it gathers a whole lot of information. And what we're doing right now is, let's see, 30 seconds. So let's see what image it pulls. Busy. So the way I have it configured right now, what it's doing is it's taking a 30-second long exposure, then it's coming back and taking another 30-second exposure with the shutter closed. Then the computer inside the camera will take that dark frame and subtract it from the light frame. Okay. And that gets rid of a lot of noise.
Yeah.
So right now, I don't know about you, but I'm hot and sweaty. The camera's pretty much doing the same thing. Ooh. Okay, what do we got?
Oh, nice.
We got something in red.
Picks up on a red filter.
Yeah, it excites the hydrogen. Hydrogen gives off red light. This is a planetary nebula. They have nothing to do with planets. Nothing whatsoever. However, they were called planetaries because through an early telescope, it looked like a planet.
Oh, wow.
So what we're looking at now, let's see if I can do a longer exposure. I should be able to see it here. Well, maybe we'll see. We're going to go to here, and I'm going to do bulb. Let's see what kind of image we can get. Okay, so we're not going to do too long of an exposure. I'm going to do 15 seconds just to see where it is in the field of view. I'm hoping it's close by. Denab was centered, but we'll see where the rest of it is. So a planetary, it looks like a planet through a small telescope. By it looks like a planet, it looks round typically. What it actually is the leftover remnants of a star that's blown out its outer layers. And the reason why it's glowing is because the white dwarf left on the inside, the core of that star, is giving off a lot of ultraviolet radiation, and it's exciting all the gas around it. So this is a dying star. Well, let me rephrase that. It's the core of a dead star. It's the remnant of a dead star.
Explosion,
Yeah. Well, you can think of it as an explosion, but it's not exactly right.
It's exploded.
Not exactly. The outer layers have blown off. Here we go. Now we got something. There we go. How is that? We got the dumbbell, and it's centered. Oh, happy days. So how about this? I'm going to take a much longer exposure. Okay? So we're going to go with more than 30 seconds. We're going to try to go for a minute. And actually, what I should have done is that 800. I can't do it right now. That's fine. So let's do a minute. In my other application, it'd be much easier to handle. This is Canon's application, Backyard EOS. I need to put in a support ticket for that one. Or reinstall an older version because this new one is not working right. I have two cameras that should be able to see it, and neither of them are working. So, all right. We're going to take a minute-long exposure. Once it's done, it'll take another minute exposure to do a dark frame, and then we'll see what we can see. And in fact, I will take this into Photoshop, and we'll actually do something with it. Photoshop. There we go. Photoshop is, of course, one of the tools of choice. I've been using Photoshop since 2.5. No. Yes. 2.5, I think it is. And 1 minute 20. Let's do 1 minute 30. Might as well. So I've been using it for a very long time. I am used to the workflow. There's other applications out there now which are dedicated for astronomy. The PixInsight is one of the more popular ones. I actually have it. I do use it, but my workflow in Photoshop is just, I've been using it for so long. It's just natural or not natural. I'm just well trained in using it.
Relearn a new program.
But the other programs do a really good job on specifically astronomy related stuff. I need to be able to download this. I need to be able to download it, but it's not going to let me. Maybe, I don't know. We'll find out. So I still have a little bit before it's done, before it pops up. In the meantime, we can try to do this. That's centered, so I'm going to take a LX mode. Let's take a much longer exposure. I'm going to take a 30-second exposure with this and see if we can find how good of an image we have of the dumbbell. I see something. There's a streak. It's going.
Are you watching that 1 minute exposure develop?
There we go.
Oh, nice.
No, that's not nice. That's I don't see anything.
Am I not? You got a bunch of stars up there, don't
No, that's a whole lot of
you?
noise.
Oh, is it? No.
That's just a whole lot of noise. Nothing but
You had
noise.
something cool.
I've got nothing.
Chris, on that note, man, I'm gonna head out. I got a 6 a.m. start tomorrow, so
6 a.m. Well, I'm going to be up at 5 again, trying to get some more photos of the comet.
you're my hero. All right. Well, thanks again for having me out.
Thank you, and drive safe. You want to stick around for just one more minute?
Sure.
All right, hang on.
I'd like to get with you. Maybe we could do another Zoom conference. Just kind of do a recap.
That's doable. Wow, check that out.
Man.
That is the
that
dumbbell.
After the dark frame?
This is with the dark frame, but it's got a whole lot of other noise in it. That's okay. Noise we can clean up. And the reason why we take multiple images is so we can stack them.
Right.
When we stack them, we average out the noise.
Kind of overlaid.
Yeah. And all that noise is just kind of smoothed out. So we're actually able to see the dumbbell pretty decently. That's not too bad. I can always bring it into Photoshop and mess with it some more. If I do open my computer. Okay, where does it go? I don't know. It should be on Canon. I don't think it's going to let me. No, it's not going to let me do it this way. Yeah. Wow, that's loud. Cicada. Yeah, so this is fine. We're able to see it. This isn't too bad. Okay, so I'm going to swing this over. I guess I'm not really centered on this thing. I'm not going to worry about it. I'm also apparently not focused terribly well. That's fine. Instead, we're going to go over... Ah, damn, that cicada is right in my ear. It's really, really super annoying. So I'm going to jump over, and we're going to do really fast Lagoon. Because the Lagoon is really, really pretty. And this is M8. So we're going to go back. 008. Enter. Enter. And swing it over. Everything's just eating. All right. So hopefully this will be in the center of view. Kill that and bring this back up. We're going to take another exposure. See what we can see. So now we're looking into the Milky Way. So we should see a lot of stars. And let me go out. I don't know if y'all heard that, but it's like this intense buzzing sound in my ear.
For sure.
So here is Sagittarius. Just all through here. When we're looking at Sagittarius, we're actually looking at the center of our galaxy. Problem is, we have this dark nebula here. It's basically dust. And this dust is blocking our view of the actual center of the galaxy. So instead what we have to do is look at it in infrared. And we can see through the dust in infrared. We've actually discovered a lot of interesting structures in the galaxy by looking at stuff through infrared, at the night sky through infrared instead of just through visual, through visible light. And it is really, really hard to think when you're covered in bugs. I will say that. And especially not when you have a... Is it a cricket? Oh, that's a big old cricket. I don't really mind bugs terribly. It's just a lot. All right, let's do 1 minute, 20 seconds. We don't have to do it that long. So another 1 minute, 20 seconds for it to come back. See what happens. I want to get a good image out of it. I want to see what that's like. Hopefully we'll see the Lagoon Nebula. So with this camera, this is a Canon T3i. This is a modified Canon T3i. What it does is it has the hot filter taken off of it, so it is much more sensitive to infrared light. It is much more sensitive to this deep red color, which is what we want. However, if I try to take pictures of the daytime with it, it looks like an old photo from the 1980s or 70s that all the blue and green pigment has faded out of, and it just looks red. Right, that should be pretty close. Pretty close. Busy. Also, this ISO I should change. So this is, I'm getting a lot of noise off of this ISO, but I don't have to do such long exposures. I think we had this issue last time. There we go. There's part of the lagoon right there. That's part of the lagoon. You can see that little reddish bit.
Not bad.
But it's not the image we want. What we want is the image over here. Yeah, I need a... That focus just isn't that great on there. There we go. How's that?
Did you just apply a filter to it?
No, I haven't done anything with it. This is raw.
Wow, that's awesome.
This is just raw. And you can see that there's haziness all through here. But yeah, this is...
So we're looking through the dust into the center of our
Well,
galaxy.
This is a nebula towards the center of our galaxy. It is not covered in a whole lot of dust. You can see some dust bands through here, but...
Is this what you're calling the lagoon?
This is the Lagoon Nebula. And the Trifid is over here. It's just kind of off to the side. But this actually extends a lot further, but you have to take a much longer exposure. Moth. So we can take a much longer exposure and get better images out of it. What I really want to do is this is the quick preview. What I want to do is just download this thing. So where is my shooting menu, flash control? There's no flash. There's no shooting menu. I need preferences, other functions. Let you select and download. There we go. So let me download it, please. I really just want to download it because I want to bring this into Photoshop, and I want to do some editing in there where we'll be able to get rid of some of this haziness here and bring out some of the detail in there. So that's what I would like to do. This is just not. What do I need to do? This? No, I don't know.
I'm already impressed that you can do this much with that rig here in Grandview, Texas. I mean,
yeah, it's not bad. So I'm going to do this. I'm going to hit, no, cancel. Let's go do that. I'm going to go for less noise. See, we got nothing. That was like a 1 second exposure. I'm going to go with less noise. And we'll just let it go. We'll just let it go. I just want to see what happens. It'll go for a bit. And instead we can talk about other stuff while that's doing its thing. So here's the Trifid. And the Trifid is called the Trifid because these dark lanes here kind of separate out into 3 main sections. 1, 2, and 3. Then you have, this is an emission nebula. So there's a hot, bright star that's giving off a lot of ultraviolet radiation. And it is lighting up this part of the nebula. This part is a reflection nebula. So this is primarily dust and gas.
What portion is the reflection?
The blue.
Or blue?
Yeah. What's happening is you have gas and dust, and then you have a star that usually it's going to be closer to us than the dust is, and the light on the backside of the star is reflecting off this nebula and then coming to us.
Okay.
And it's usually dust. It's not usually gas. If it's gas and it's a hot star, it's going to get lit up and it's going to be red. Now, it's not always red. We have actually have a camera here that's a mono camera, and it's got a bunch of filters on it. So what that does is it takes the filters are the same ones that the Hubble telescope uses. There's one that takes a picture of hydrogen alpha. It's the excited hydrogen gas. There's another filter that takes excited sulfur gas, which is also a red color, but it's a little bit different than the red color from hydrogen. They're two similar reds, but they're far enough apart that they're two different reds. And then there's another one which does oxygen. And the oxygen is like a blue-green color. So the Hubble palette is called SHO. So you take the sulfur and you set the sulfur channel as red. You take the hydrogen and you set the hydrogen channel as green, and take the oxygen and set that as the blue channel. Now you have RGB. It's a false color image, but just by looking at the image, you're now able to see here's where the hydrogen is, here's where the sulfur is, here's where the oxygen is.
Differentiate.
Just so you can differentiate. Cool. So, 2 minutes. All right, cool. 2 minutes, let's see what happens. And I don't have a chip in there. Well, that was brilliant of me, wasn't it?
Do what?
I don't have a chip in that camera. No wonder I can't download anything. No, it should let me download to it, but I guess I'm not getting any pictures because I don't have a chip in there.
You like a micro SD?
Yeah. Well, I've got chips. It's just yet something else I forgot.
On that note, Chris, I'm outie.
Thank you for coming by.
Thank you for having me out, and yeah, let's do a Zoom.
All right.
And you'll have to show me how to record on that.
Oh yeah, that's no issue. Well, actually, the host records.
Okay. Well,
but
I'll host then.
Yeah.
'Cause I'll want to add that to our little.
Oh yeah, we can actually do. We'll talk about it later.
Yeah.
It's no worries.
Sure, man. Okay.
Cool. Thank you.
Thanks to
Drive safe.
Followers.
I have followers?
Sure you do. You had like 15 people watching.
Oh man.
I think your videos are doing pretty good too.
I have
some on there
followers.
that are thousands and thousands of people.
Wow. I didn't even think about that. So
Okay, well don't get eaten alive out here.
I will try not to. These guys aren't biting, but now that you've left, they may attack me instead.
They're gonna migrate for sure. All right, Chris, thanks, man.
Okay, thank you. Drive safe. Quick preview. No, that's still the old one. Let's get rid of that one. And is it still going? It's still going. So as soon as that's done, I'm going to pop in this chip and hopefully get some images on there. But we'll be able to see the lagoon, hopefully in some better detail. And see how that goes. Yeah, I don't quite have good focus on this one. But tracking isn't half bad. We'll just see what the camera says. Still going. Yep, still busy. So it's not going to let us do anything. There we go. Nope, still busy. I thought I was almost done. Almost. So it's 11:39. We haven't seen a whole bunch of objects. Oh, there we go. Alright, that's pretty. That's really pretty. So the stars are fairly round. I'm pretty happy with that. The tracking is pretty decent. I think if we zoom in, it'll be a little bit streaked out, but we are able to see some of these dust bands coming through here. See what it looks like on there. It looks pretty good on there. I'm just going to come in and move that. No. Let's see if I can do this. There we go. There we go. Now it's just me. I'm terribly sorry about that. So we have this image. I'm going to go ahead and put the chip in the camera, so at least we have something. But it is a halfway decent night. Okay. There we go. Camera settings, remote shooting. Let's just go back to that. So we got this manual. All right, we got that. That was me jostling it. And what I'm going to do is knock this way down, because I want to see if I can get the focus a little bit better. So we got some bright stars in there. Yeah, let me see if I can get a better, slightly better focus on this. Yep. Back in the other direction. Much smaller stars. A little bit more. A little bit more. It's just going to jostle it. So what I can do is actually something really neat. And let me see if I can find it. I've got it somewhere. I just have to go find it and not trip over 100,000 cables. It is somewhere around here. Somewhere. I did have it. No, I had it. Here somewhere. But it's not here. What? I don't know where I put them. Oh, there we go. I did have them. Here we are. I just have to undo this, undo this. There we go. So this is called a focusing mask. I guess you can't see it very well. How's this? The focusing mask, when I put this on the front of the telescope, lets me do something really neat. If I can just tighten this up. This is the back side. I didn't take the paper off of it, so it's a bit easier to see. These cuts inside the screen create a diffraction pattern. What that means is when I put it on the front of the scope, like that, you can now see these stars look weird. But this gives me the advantage of now I can actually look at them and I can change where I can see how badly out of focus I am. And I will show you, this is an out of focus pattern. This is much better. This is almost there. That's pretty close, but I'm going to make a much longer exposure because I want to see these things a lot brighter. Okay, this is very, very close. Do that. I know which direction I moved it. And I'm looking for a symmetrical pattern. I want this to be as symmetrical as possible, and I want it a little bit more than that. So almost there. And these spikes are what I'm looking at. And you can see these spikes here, here, and here. And I want to go back in the opposite direction now. Okay, so I'm going in the opposite direction. And there we go. Okay. That is symmetrical. I want to see an even distance between this spike and this spike, and this spike and that spike. This is symmetrical. Now I know that my image is going to be focused. Then I can take it and rotate another direction. Let it settle. Take another image. And I still have that symmetry. So this tells me now my image is... or my telescope is properly focused for this camera. Yay. Okay, so we can take that off. And now I'm going to have much, much smaller star images, which is what I want. I'm picking out more detail, which is what I want. And we're going to go to the Trifid. The Trifid is right next to it. M20. And finally, M020 and enter. 0, enter. Enter. So it does not have to move very far. I am going to be able to take this. Let's see what this does. Okay. So we're close. We can do a much longer exposure. I'm going to do that's too much. I'm going to do a 30-second exposure. 33 seconds, that's fine. We'll see what happens with that. Come back here. Let's go ahead and take an exposure with this too. So we're at 800 ISO. And well, we'll see. Let's start with 60 seconds and go for there. Let's see. What would this be? No, nothing important. Oof. Uh-oh. I can't connect to the chat. Something's not right. So I'm going to refresh this and see what happens. Apparently something's going on. Guess I'm still streaming. Okay. Alright, I am back on the chat. So, okay. Alright, cool. Still got 11 people on. That's still nice. Alright. Got a little bit of motion. That's fine. I'm not too worried. This is really, really zoomed in. And we're not doing anything special with it. So, oh, I guess I should stop. 1 minute, 10 seconds. So we're going to see what the Trifid's like in 1 minute, 10 seconds. Have a little bit of motion. We could... No, I don't know. I think what I'm going to do is swap it out for a different camera. I think that's probably what I should do, but oh man, I don't want to mess with it right now. Though I should. I really should. Because this chip has a really, really small field of view. And we can see that. We're not really seeing a whole lot in there. This camera is not really meant for this telescope, this focal length. But that's fine. Alright, it's still going. Yeah, we're seeing some star trailing because it's unguided. Some images are okay, some are not. And come on, give me something to work with. There we go. Okay, here we are. So we see the blue bit and the red bit, and we see the lagoon over here. So I'm going to now see if we can download this image. Quick preview. Download. Pictures. Download. Destination. Ooh, I do have pictures. Alright, fine. Let's see if we can find in there. I really wanted to send them somewhere else, but that's okay. Oh yeah, we do have... Oh, cool. Alright, we've got something at least. Which ones are today's? View, details, date. Nothing? Nothing? Camera roll? No? Anything? Oh man. Download images. Yeah, that's what I want. I should be doing it by the date, and it's not doing it by the date. Oh, that sucks. Alright, fine. Do this. Yes, fine, whatever. Details. Keep going. This is weird. I haven't had this happen before. Not current pictures. Okay, I think that's it. It's the whole list. So we're going to get Trifid. These are the ones from now. Let's just do raw. It's better to do raw anyway. Where can we drop this? Where is my computer? There's that. Fine, we'll just drop it this way. Pictures. Let's do that. Okay. I should have a CR2. There we go. Bring this into Photoshop. Open with Photoshop. And because this is camera raw, we can do a lot more with it than we can with just a JPEG. Fine. There's a new interface. There we go. Yes. Just. That's fine. That's not the image I wanted. It's a neat image, but that's not the image I wanted. That's not the right date. That's not the image I wanted. Let's try this again. So I was on the camera. There we go. Date. 7/5. That's not. Didn't we just take this picture? We just took this picture. And today is the 11th. So it's not. I guess this isn't writing to. It's not writing. Well, it's not one technical issue after another. All right. Try this again. Canon. No, come on. EOS. Sometimes I think I should have stayed home. EOS utility. There we go. Not version 2. Okay. I really want this thing to download to there. I don't know why it's not doing that. Download images. All images. All names. Do not modify. Remote shooting. Also, there we go. See, that's... Okay. Alright, let's do another image. I'll do a minute. Let's see what happens with 1 minute exposure. So what I want to do is be able to bring out the colors very quickly and easily. The emission part of the nebula and the reflection part of the nebula. Now we've got dark skies here. I want to do a galaxy next. We did a galaxy last time. Let's get out of the Milky Way and shoot a galaxy. Oh, we got the M22 Sagittarius cluster. That's neat, but I want to do a galaxy. Barnard's galaxy. Barnard's galaxy. That's an irregular. That might be hard to pick out. What is a good galaxy? Got the veil. Okay. Ooh, Andromeda's... Oh, it's just barely popping up. You know what? Might as well try for it. We'll see what we can see with the Andromeda. But like I said, Andromeda's big. So remember, the full moon is just a half a degree across. This thing is 2 degrees... 3 degrees across. 3 degrees across is 6 full moons across. Wow, it's big. Oh, here we go. This right there, this is, well, hard to see. That group right there is an NGC object, a new general catalog in its own right. It is part of the Andromeda galaxy. It is actually, I think this is it's a cluster. I think this is a star-forming region. I'm not 100% positive in Andromeda, but it's something that we can see from here, and we can actually identify individual stars in Andromeda, which is pretty neat. Whoops, that's a bit long, but that's okay. Let's just get that data. Hopefully it'll be decent. I'm hoping there's something in there. I'm hoping I can see that. If not, I gotta run over there, grab that chip, bring it back. So while that thing's going, what is it? M31? Yeah. Back. 031. Enter. So we're gonna go over. And yeah, I am kind of hamstrung without having the direct computer interface. It doesn't make it very much fun. It's a lot more difficult to do. So I'm gonna get that out of the way too. Anything at all. Anything at all. Still busy. It'll send it over when it's ready. In the meantime, let's see what this shows. That is probably the core of Andromeda. It's fuzzy. Can't really see much of it. And we do the histogram stretch just so we can see something out of it. But that's it. That's just noise. Well, it's probably something on the sensor. But that's the core of the Andromeda galaxy. And if I took a longer exposure than 30 seconds, if I did it, no, let's drop it down to like, oh, I don't know, 80 seconds or something. Oh, there we got a little bit more detail. So it's going to go through a minute and something. Oh, here we go. Okay. So we have that. We have a little bit of streaking. It's not terribly bad. We can deal with it. But I really want to pull that image down. But I don't see it on here. Will it have saved it locally? Yes, it did. Yes, it did. The JPEG only? Alright, let's drop this in Photoshop. Let's see what we can do. Alright, here we go. What is that? No, we don't need that. I don't need to learn Photoshop. So we've got a little bit of streaking. Because we're unguided. That's fine. We'll live with it. Oh man, I forget. This is not set up the way I want it. Is it all? Yeah. I want to bring out these colors though. So we're going to go adjustments. We're going to go to levels, and we'll do something neat. So typically, what I like to do is bring it in like this, bring it in like that, and then this we can center it out, but not necessarily. We want to make it aesthetically pleasing. There we go. Hit OK. Now I can come in to curves. Adjustment curves. We'll see what this looks like. Something like this. Bring this up just a bit. It's not bad, not horrible. Come in, you can do something like auto color. No, auto tone. Yeah, that's a bit better. Keep forgetting. There we go. So we see a little bit of the blue. We see the red really stand out. There's a lot of vignetting on this, which is fine. And we can see a cluster over here. You can see the lagoon. So we can see some detail through here. This isn't too bad. Now, I'm not happy with this picture. They're streaking. That's not nice. But also, there's a whole lot of noise. If we look through here, all these red dots here. Actually, no, I think those red dots are fine. These are probably stars. There's something I'm looking for specifically called a hot pixel. And I don't see any off the bat. They're just long streaks. We got some red stars. This is actually dust that's covering the sensor. I just haven't had time to clean it off. But what we could do then is, with this image, is just go in and get additional pictures, additional images, and get the best ones. That's too much. Or histogram stretch. Yeah, it's just too much. It's still too low in the sky. I think Andromeda is just too low in the sky, but we can just do a quick view. Let's see what we can get. I just want to do a 30-second exposure. Nothing more than 30 seconds. So we're pretty low in the sky, and actually it kind of looks like is that cloud? I think there's a little bit of cloudiness there, so it's not ideal. But we're finally getting some decent skies, and I may start turning out some of these lights. No, that's probably not a good idea, because if I try that light over there, that will mean that all the bugs will come in towards these lights, and I don't necessarily want that. In fact, I kind of want to kill this light. There we go. Oops, 37, 38. Got some mods here. Bottle fell down. So many bugs. So many bugs. I really don't think I've ever seen this many bugs in one place before. Not even in an anthill. I definitely have to keep the water bottle closed. I don't want to eat anymore. Uh-oh. I'm not getting good connection. Uh-oh. I hope that you're still seeing something on YouTube, because I'm getting some streaming error, so it might be a bit slow. Okay, what am I seeing? I'm seeing clouds. I'm not seeing Andromeda anymore. This is just clouds. All right, so got a spot here. This is pointless. All right, what else can we look at? Let's go look at some galaxies other than Andromeda. Still too low in the sky. There's some cloud around there. Man, these would be really nice, but M92 with Hercules. Alright, let's do that. Oh, Whirlpool. We can do Whirlpool and Pinwheel. That's for the northwest. It's going over in that direction. Northwest, Pinwheel. Sunflower Galaxy. Did we look at the Sunflower last time? I don't think we did. We got Bode's Galaxies, but that's pretty low as well. You know what? Let's just do Bode's Galaxies. There are 2 galaxies. One is in... Yeah, let's do that. So this is M81, M82. M81, M82. 081. Enter, enter. Alright, so this is going to swing over. That's going to swing over. And I have a... I have an idea. I don't think it'll work well, though. I thought about connecting that camera, but I don't think it's going to work well. So let's get that on and go ahead and do an exposure. Once it's done, let's go 30-second exposure, just to make sure that we're still centered where we want to be. Minimum exposure before you start to see streaking. Depends on the mount, depends on a whole lot of factors. In this case, we can do a 5-second exposure and there could be streaking. We could do a 10-minute exposure and there's no streaking. So it's so many factors. Is there wind? Is the mount shaking? Is there slop in the gears? Some of the newer mounts that are being made, they're not using gears anymore. They're using belt drives. And there's supposed to be a lot less periodic error with them. It's supposed to be running smoother. I do not have one. This one is a gear drive, so it has a worm gear, which looks like a screw on an axle, and then it has a toothed gear that is moved, like a circle with teeth on it. So gears like that have something called periodic error, and it means that 1, they're not perfect, but 2, that there's a little bit of slop. So if you graph out its motion, it's basically its acceleration. Instead of it being a smooth line for rotational acceleration, it dips or it rises and it makes a pattern. Sometimes it just dips and goes on, sometimes it goes faster, but that periodic error is something that happens in the geared system, and in some cases it doesn't matter. Like in a car, it doesn't matter, because the way it's made and it's and what it's used for it doesn't need to be that accurate. For something like this, it needs to be very accurate. And so the newer stuff that use belted drives and stepper motors, they're going to be more accurate. And you still have some periodic error, but it's very, very little. And you can train the drive so that when it gets to that point, it either speeds up or slows down enough that it gets away from that. What do we have here? Here we go. Got something. So those 2 fuzzies, that's really it. With this camera, there we go. So there's 1 galaxy, those are 2 stars. So we're only looking at 1 galaxy. This is probably the spiral. Not a very good image, but that's fine. We'll pull it out of this one whenever it's ready. So this is Andromeda, still not ready. Still not ready. Alright, I'm going to try to do something else here. So we've got that camera. Let's see if I've got disconnect this. Instead, connect this. Drop that. Alright. See, this is a very, very small chip. I'm going to have to find a place to put this down that's not covered by bugs. Alright, so that's ready to go. Let me think. A good course of action with this. I think be able to do this. There we go. New image coming up. Is it in the clouds? No. Well, it's low and we're looking towards the north. So it's got light pollution in there. Let's see if we can get rid of it. First, I'm going to plug this in. Get it on here. Alright, so I'm going to put a different camera on. Hopefully this will work. No card in the camera. I need to go get a chip. So I know where the chips are. Always carry spare chips. Oh. Alright. That was fun. So this is not a big chip. Doesn't need to be what we're doing. What I'm going to do is switch the video. Okay, fine. A stars, nothing. Okay, probably pull this out. I just need to find a bright star. I see nothing. Alright, we have to get a bright star. In the meantime, we have two galaxies, so let's deal with them. Alright, so we have a edge-on spiral, or a regular thing, and then we have a regular spiral there. And remember, this is a wide field view, so I'm going to go into Photoshop. I'm going to go ahead and open that one up. Why don't I just do it this way? Alright. So lots of light pollution. Let's just do something quick and dirty. Yeah. Hey, cool. What did we get here? We got a satellite. We had a satellite that ruined our picture. Look at that. And we know that's on an airplane because if it was an airplane, there'd be dashed lines. This is instead a satellite. It went right in between. In some ways cool, in some ways super annoying. And you can barely see it now. Just there. Hey, is this another galaxy? Could be. Might be a star. It's hard to tell. It's a fuzzy. So let's try this. Auto color. Nope. Let's see. Let's just do a usual way of doing it. Adjustment, curves. So I'm going to drop this down. Make it as dark as possible. And bring this over. Bring this down. Geez, I don't want it quite like that. What are we looking at? Nope. What does auto do? Let's see what auto does. Yeah. Because I want to make this as dark as possible. And it's not going to be a good image. This is pretty much a throwaway image. We're not going to get much good out of it. There's some other applications that are a little bit better. It's not a very long exposure too. So we can see that is a spiral. It doesn't look like a spiral. And that's our edge on right there. That's some bugs in my hair. So if we go to here, what we're looking at, here's a spiral, and then here's the edge on. Cigar galaxy. Yeah. So, edge on right there. Edge on right there. So we're looking towards north. That's probably not the best of places to look. So let's look at something else. I want to see what galaxies do we have towards our south. So we can at least get something. Yeah, we're looking past north. So we're looking back in town, basically, and we don't necessarily want to do that. What do we have overhead? We have the veil. We've done that. We have another veil. Pegasus cluster. No, Saturn Nebula. These are all neat, but I'm looking for galaxies. Neptune. Maybe we can see Pluto. Have you ever seen Pluto? I don't recall seeing Pluto. So maybe we can see Pluto. It'll be near Jupiter. Okay. I don't know. I don't know if we'll be able to see Pluto. It's going to be very, very dim. It's going to be really, really small. And it'll be just absolutely lost. I'm pretty sure we'll be able to see. On the plus side, we can see it better now than we used to. Bernard's Galaxy. What the? June bug. That's an irregular. That's not really much to look at. I want to get something better. Eagle Nebula, we did that. Wild Duck Cluster. Dumbbell. Ring Nebula. We haven't done the ring yet. Let's just do the ring. M57. So the Ring Nebula is another planetary, and it's pretty. So let's do Ring Nebula. Back 057. Enter. Enter. Yeah, I've got to get this thing fixed. Oops. So this is another planetary nebula. So this is a star that blew off its outer layers, and you can see there's lots of green in there, blue-green. So this means that there is a lot of oxygen in there. Center. So we should be able to do a fairly quick exposure with this one. I'm not going to mess with the very long one. So we'll do that. I probably should have focused it first, but that's okay. We'll just do 20 seconds, see what we get out of it. Or maybe less. In the meantime, I'm going to grab another cable, such as this one, and plug it in. So many cables. So much to trip over. Hopefully something's coming up. Probably. Yeah. Right. Battery is empty, which means I gotta go get another power supply. I believe it is somewhere over here, somewhere close by. That is not it. What? Camera battery. Oh, technical issues. I stepped on a cable. My cousin's over here. I stepped on the cable that controls the mount from the computer, and I ripped it completely out. Even if I had my cable crimper, I do not know what the pinout is, what the wiring pattern is.
Ethernet?
No, it's POTS. It's was it plain old telephone? It's what is it, RJ3?
A telephone kind?
Yeah, it looks like a telephone.
Is it a 4-wire?
Yes, but not only is it a 4-wire, there are only 3 wires in it, but I don't know what the wiring pattern is. So if I don't know what the wiring pattern is...
Would a 4-wire work?
No.
Special? It's
special. It is a 3-wire that connects to a serial port.
Oh.
Yeah. Okay. And again, I do not know what the pattern is. So I'll just have to, I'll have to fix it. I'll have to figure out what the pattern is and use my cable crimper to do it the right way. Okay. Yeah, I think I should have some POTS terminals somewhere. Once you've been doing IT for as long as I have, you tend to gather equipment and bits and bobs and ends because, hey, they might come in handy. And, well, you know how we are. Yeah. Alright, so that image come in? I think an image came in. Something came in. What came in? Oh, I'll get that. Okay, what do we got? We got, that's it. That would be the dumbbell. It's really, really small, but it is there. And because it kind of looks like a little bitty round planet, they used to be called, or they still are called, Planetary Nebula. They knew they weren't planets because they stayed in the same part of the sky all the time. They didn't move around like planets do, but it kind of looked like a planet, therefore might as well call it that. Planetary Nebula. So now I have enough power. No power. There it is. What I'm trying to do is find a star so I can focus this thing. I've got nothing. No stars. I need to go find a bright star. So I actually have an idea. So we can talk about the dumbbell. I keep stepping on that thing. I'm going to bring this into Photoshop so we can zoom in on it. And so this is an 18 megapixel image, but I want to bring it in here. Here we go. I don't know why I'm just doing the JPEGs. I wish I was doing the RAWs. So here we can see the red of the hydrogen. We can see the blue-green of the oxygen. And this is not that bad of an image. This is actually pretty good, but it's a fairly short exposure. We just want to make sure it's in there, in the field of view. And it's pretty close to the center, so this is not bad. But here's what I want to do. Here's what we're going to do. I'm actually going to come here, and we're going to do something a little bit different. What I want to do is get this camera ready. So we're going to get it onto Vega. Sure, why not? Let's get this onto Vega. And back. Under stars, named, enter, or we can do Deneb. Let's do Deneb, because there's actually a region I want to get a good image of, but I want to, at the same time, align this thing. Or not align it, get one camera. Anything? There we go. Photos. That's why. So I can't get a good focus because I have an extension tube. I'll take the extension tube off and put this thing back on. Now I see an image. I'm just going to do it quick and dirty. Maybe not that quick, maybe not that dirty. But I'm going to use the focus screen again. Oh, there I put it. That's always fun. So many bugs. Now I put the focus screen back on because I have swapped out to a different camera. If you swap out to a different camera, you have to fix your focus. be pretty close. That'll work. Okay. So I've got that down. Now I have to connect it. I don't know how well this is going to work to have two cameras and use the software this way. I have not done this before, but my usual software is not working at all. Really, really annoying. I'm going to have to put an older version on there or something because it's just not working. I thought, hey, new version, upgrade, it's going to be fine. No, it's not. Alright, that's good. Just be careful, don't kick anything out. Alright, so this is still on Denab. Where is Denab? Here's Denab. So this is North American. This is not what I want to look at. I want to go to the Satyr region. Here we go. Yeah. There's actually a region over here. Or we can do the Veil, which is big. And my wife is asking, when am I coming home? Probably pretty soon. I'm just covered in bugs, and we're having technical issues, but I want to get a couple more images in and see what we can do. Alright, so if I'm on Denab, I should be able to come... I don't know how this is going to work.
Here's a result from search.
No, that's not what I want. Thanks, Google. What I want to see is a different connector. So, what are we looking for? EOS again. So the cock has crowed once. It's probably telling me it's time to go home. EOS 2 utility. Can't do a second one. I don't know if it can handle it. I don't know. We'll find out. Anything? No. Yeah, that's not going to do it. Alright, so I want to see what happens if I do this. We're going to look at the Veil. So the Veil is a supernova remnant. We haven't looked at the Veil before, so this might be a good object. Yeah, I think this will be close to the end. 5992, so we're going to go Deep Sky, NGC, enter 5992. No, this isn't right. 6992. Back. 6992. Enter. Yep. Enter. It's going to be close by. And nice and still. So what I may actually do is just take a manual image. No, I don't want to do that. Close that. EOS tries again. Oops. How can I switch cameras? Well. Alright, let's go ahead and take an image. So, the Veil Nebula is a supernova remnant. What that means is that at some point in the past, somewhere between this loop and this loop, a star exploded. And this is an explosion, not like what causes a planetary nebula. Planetary nebula is, that's going to be caused by a star about the size of our sun to a little bit bigger. And at the end of its life, after all the hydrogen has run out, it starts to burn helium. And there's something called a helium flash. And there's a lithium flash, and an oxygen flash, nitrogen flash, and carbon flashes too, for heavier and heavier stars. So what that means is the actual gas on the outer layers is still hydrogen. The core runs out of hydrogen. When it does, the gravity of the star starts to collapse down. When the pressure gets high enough and the temperature gets high enough, helium starts to fuse, and that's the helium flash. As soon as that starts, that core collapse stops, and now there's an expansion wave. Well, it's strong enough that it will actually blow out the outer layers of that star. Not as an explosion, it just, not terribly gently either, but they do fly away from the sun, from the star. And this will eventually happen to our sun as well. So it'll blow out and make a planetary nebula eventually, as it gets bigger and bigger and bigger. And then it gets heated up by the white dwarf, the core, the remnant of that star. For a supernova, they're going to be much, much larger, and when they explode, it's a real explosion, and they're some of the most energetic events in our universe. And sometimes they can outshine an entire galaxy, just for a little while, just for a few days, sometimes even a few hours. But there's this peak where they're just incredibly bright. So at some point in the past, a star exploded, and these bits of gas are what's left over. And they're actually being lit up. So over here, this part, the western veil, is being lit up by at least this one star, probably more. And down here, there are additional stars that are lighting this up. So there are ultraviolet stars, and this is just remnant gas. There's not enough here to form another star that's in one place. So this isn't going to be forming anything. Excuse me. So many bugs. It's hard to concentrate when you have cicadas and there's June bugs and crickets, and I don't know what that is. That looks like a giant mosquito. But it's a stink bug. Oh, that's lovely. That's exactly what I need more of. And these little bitty things, I don't even know what they are. But I want to keep crushing them. And then there's, oh, that one's dead. Whoops. And then there's stuff which I don't even know what it is. And then there's stuff in my hair. So this is a fun night. Technical issues. Oh, at least I saw a meteor. Well, that's nice. I just happened to look up and saw a meteor to the north. To the northwest. So very, very quick. And you know what? It looks like it's getting kind of hazy. Hang on a second, let me see. Alright, there are clouds moving in from the northeast. So I think we'll see what we can see with this, and then I think we're pretty much going to be done because they're starting to roll in overhead too. There we go. So this is the Eastern Nebula. We can see. Good thing no bugs flew in. Come on. This is what we're seeing here, and we've just got a lot of haze that's starting to come in. This is more than I'd hoped for. Tonight, I thought tonight would be a pretty good night. Let's get this into Photoshop and see what we can do. layer. I'm going to do, maybe we can, oh wow, okay. Now, I don't care how badly this image looks right now. What I want is instead to pull out some details. I just want to see what this thing looks like. Let's do auto, just see what auto says. Yeah, I would rather see some extra details right now without regards to all this blue background stuff. Yeah, so this is what we're seeing. With the Veil Nebula. So we are able to see some details, and this is one of the things that you need a pretty decent sized scope to see. You can barely see it in a 10-inch if you have filters on it. A 12-inch or a 14, 18 or 20-inch, you can see it much, much better. I've actually seen this thing through a 30-inch telescope, and it's very, very nice from dark skies. You can see a whole lot of detail just with your eye in a good telescope, a large telescope. But these are small telescopes that I have here. One is an 8-inch. The one we're using right now is a 4-inch. They're not big telescopes. They're not meant for looking at deep sky objects with your eye, with an eyepiece. But as photographic instruments, they're not bad at all. So we can pick out details like this. Now, what I really want to do is connect to the other camera. But it's not letting me. It's just not letting me. Why is it not letting me? Oh, continuous manual. Oh, I wanted mirror lockup. Okay. That's fine. So I'm going to kill that, and I'm going to try something else. Net or no. Aha, now it's going to let me do it. So now I can come in here. That's what I thought. I'm having problems with that one too. And I think I know why. Alright. So let's see if there's anything else that we can find, and then we'll call tonight. It's getting late, so what time is it? It's 12:30, 12:37. I still have to pack up, so y'all can go to sleep, but I still have to pack up. I've seen the ring. Let's see what else is interesting. I really kind of want to get this M29. Is this what I want? No, that's just a cluster. This whole region around Saturn, that's what I want to get. There's a whole region around there, and I'm going to go back. So I'm going to do stars, named, and I have to scroll through a billion of them. Maybe not a billion, but a lot. Russell Hague, Saturn, there we go, enter. So this is close by. I'm not going very far, and I hope the clouds don't come in before we can get this. But this is actually it's an interesting nebula. It's not showing up on here at all, but it's a really pretty region, and I want to see what we can see. So again, we're doing a wide angle here, but I'm really happy with the setup. I'm just not happy with the equipment right now. Issues with cameras. The computers all seem to be running fine. Actually, no, I'm having issues with the connection. So I'm wondering if my cousins are watching something right now, and it's causing it to slow down. But yeah, it's hardware issues. So I'm going to have to go back and see if I can fix some of these issues, fix the cable. And then try again. So I am going to do another star party on the 27th. This is in 2 weeks, I believe. Yeah, 2 weeks on Saturday, whatever that Saturday is. When is it? 25th. Sorry, I will do one on so not next weekend, but the following weekend on the 25th. That should be close to the first quarter moon, so we'll be able to do lunar viewing, and we also will be able to do Jupiter and Saturn. And I'm going to try to set up a different way of looking at Jupiter and Saturn, see if we can pull out some more details from them. But I'll have that set up ahead of time. So again, on the 25th, I'll go ahead and try it. Again, but that does depend on weather. So if the weather is going to be horrible, then there's not much of a point in doing it. Let's see, a minute 32 seconds. Let's see what a minute 32 seconds is like at ISO 800. I've got to fix the software. I got to make sure Backyard EOS works, because it's not working at all right now. I'll probably have to install an older version on there, because I know that one worked. One of my cameras is not responding well. I still don't know why. Is that a mosquito? I think it's actually a mosquito, but it's not attacking me. It's not going to attack anyone else now. So many bugs. So many bugs. I think I will have to actually dump most of this just in the car as it is. Hope for the best. And I will leave the lights out for last so that the bugs stay on the table and don't get carried with me. Because if I bring all these home, my wife will be rather upset. And I would not blame her. Not in the least. So a minute 30, I don't think this is really long enough. This should be something like a 5-minute exposure. If we had the time, I would do this as a 5-minute exposure instead. Come on. Any little bit now. Any minute. Still going. There we are. All we're picking up is a star. That's kind of a pretty image, but I don't like that. That halo around there? No. This means that the clouds are moving in. And if the clouds are moving in, then we're pretty much dead. Oh yeah. Yeah, the clouds have moved in. They're almost, the thin stuff is overhead. And yeah, we're not going to be seeing much anymore. So toward the west, we have the lights. That's not going to work very well right now either. Jupiter is almost due south, along with Saturn, so it's up high in the sky. You know what, let's just swing it on Jupiter. Swing it on Jupiter, swing it on Saturn. Let's see if we can see something a little bit better this time around. Back. And then we'll call tonight. I'm tired. Solar system, Jupiter, enter, let's go. Yeah. Let's make sure it's pointed at Jupiter. I don't know if it is. Let's find out. So many June bugs. I swear, if I go home and there's 100 bugs that come out of my computer, I'm not going to be happy. Live view shoot. Yeah, my back is killing me. I'm getting tired here. 200. There's Jupiter. Oh, we have changes in the moon's positions. Looks like Io and Europa have come together. It's gone a little bit past here. I think Io is swinging back through. So that's interesting. Let's get way down. Not that much. That's not too bad. Hey, we got the great red spot. That's not bad at all. I wish I could zoom in more, but this thing doesn't let me do it. This is max zoom. Okay, so we got the great red spot right there. And I'm betting it is the Great Red Spot because it's been a couple of hours. And let's see, where's Jupiter? Back towards the south. Jupiter, Jupiter, Jupiter. Maybe we'll be a better image of Saturn as well. Jupiter. Look, there's Jupiter. Yep, Io past Europa. And there it is. See? Great red spot right there. Center. So we've got the great red spot right in the middle. And we're able to see that right there. Remember, this is a small telescope, so the resolution isn't that great. But it is what it is. We can see the great red spot. That's not too bad at all. You can make out what it is. So, let's look at the other moons. Slow that down. Yeah, that's actually a little bit better right there. We can see a little bit of color, but that would be the great red spot. If I had a different camera with a tiny little sensor on it, you might be able to pick out some more details, but I don't want to swap it out at this point. But we are seeing Jupiter. We are seeing the great red spot. I'm going to slow this down a bit more to where the planets or the moons come out. So here's Europa, the one at the bottom, and then the one at the top is Io. A little bit brighter. And over here, Ganymede and Callisto. Yeah, Ganymede and Callisto. Ganymede's probably the bigger one, Callisto's the smaller one. Let's see. Ganymede. Oh, it's way out. Callisto's. Oh, there's Callisto, yeah. Right, Ganymede and Callisto. Nope, no, not that one. Let's see, that one. Ganymede and Callisto. It's not too bad. Alright, let's do Saturn. Maybe we can pick up something interesting. Maybe Saturn's actually going to be better now. Solar system, Saturn, enter. And Neptune may be up as well. There it is. Cool. So a bit smaller than Jupiter. Almost as wide. And we're not getting too much more detail out of it. I'm going to see if we can. Yeah, we're not able to see too much. Again, this is a wide field telescope. I want to see if we can see some of the moons. There we go. Are we able to see any moons? Sometimes you can. I don't see anything right off the bat. Let's see, where should they be? Jeez. Where is Saturn? There's Saturn. Phoebe. Okay, yeah. Oh, we got a bunch of comets around there. S? No, not comets. Alright, so we have some. Titan is way off. Titan's the one that we can see. And the others, I think this telescope is just a little bit too small to see some of these. Yeah, they're going to be close in. Titan. Titan would be up here or down here. Can't remember which way. But in any case, we can't see Titan either. Alright, so there's Saturn. Wish we could see some of the moons. There's something that pops in here every once in a while. Yeah, it's just so hard to tell. don't think that's quite it. Could be, but yeah. Alright, so what do we got left? Saturn, Neptune. Neptune's going to be this little bitty bluish green ball. Let's see, where is Neptune? There's Neptune. And you're, oh, this is going to be way too low in the sky. Way too low. That's it. That's probably it right there. Yep, that would be it. Ta-da! That's Neptune. It's little, it's blue, it's round-ish, but it's definitely not noise. It's staying there. You can see all the flickering around it, all the heat noise, but that's definitely just staying there. So that is Neptune. It is low in the sky. We've got cloudiness. Not back there. There's not any cloudiness back there. But that's Neptune. It's not a whole lot to see, but it is. It is there. All right. It is 12:49. It is late. I'm tired. I'm really tired. I've been up since 5 o'clock this morning without much of a break. So I'm going to go ahead and sign off. I need to pack up. I thought about leaving this stuff out here and coming in tomorrow. No, I'm just going to pack it up. I've got so much work I got to get done with this that I don't know if I'll start tomorrow or start working during the week, but I've got to get ready for the 25th because this is not ideal. What are you doing? I've just got bugs everywhere. I would not be surprised if they are in my vents. On the plus side, I'm not being eaten by bugs. I take that back. I do have a couple mosquito bites apparently on my feet. But all in all, I'm not being eaten alive. They're just kind of sitting on me, which is weird because usually mosquitoes, they like me, but apparently not today. Instead, I have big old June bugs, and I really don't know what these black things are. They're little bitty, tiny. They look kind of like ants, but they're not. And they have wings. So, all right, I'm going to sign off. Thank you very much for joining us, and I am terribly sorry about all of the technical issues, but I will go ahead and deal with them for next time. So hopefully it will go much smoother. I will have everything set up way ahead of time and aligned back at my house. So we'll go from there. Again, thank you very much, and good night.